Hello?
Hi,
Hello? Am I audible?
can you hear me? Yes, I can hear you, Soumya. Can you hear me? Hold on. Hey, Soumya, can you hear me?
Yes, sir. Like 1 minute, let me invite all the judges to the stage.
Sure,
So,
definitely.
okay, so I'm not getting the full name. 1 minute. Ashish Sharma, Joydeep, sir. And who else is here? Jaskaran Singh, sir.
Yeah, now it's there. Now it's there. Am I audible to all?
Yes, sir.
Great.
So, we have to invite four judges.
Am I audible?
Yes,
Yes, sir.
Ashish.
Soumya, can you drop me from panelist and invite Rajni?
Yeah, sir, 1 minute.
Yeah, and she will be the initial one. So
Okay. 1 minute. Hello?
Hello everyone.
Yes. Is there anyone whom I need to invite on stage apart from you guys? Hello, ma'am, and sir,
Soumya, your voice is not loud enough. Not sure
okay,
it will be here.
1 minute. Now it's
Now
loud.
it's perfect. Perfect.
So my name is Soumya, and I would be the event coordinator with my co-event coordinator Anul Rajiv. We will be coordinating this event.
Hi, Soumya.
Okay. So there are certain rules by which we will be following. Have you got that list or that?
Didn't get any list. Glenn, did we get anything? Okay. I'm not sure Glenn
So
is a speaker right now. Yeah.
first I will tell the rules that the participant would be following. So we have to ensure that that we will be ensuring that each presentation time would be 15 minutes presentation time and 5 minutes Q&A time. We have to also ensure that any IIT won't disclose its name, and the procedure will be each IIT, the participant, the top 5 participant from each IIT will raise their hand. We will invite them to stage, and like they will be showing their presentation, and after that the Q&A round will follow, and after that there will be a 5-minute break, and in that break we will be revoking them out, and we will be inviting the participant from the next IIT. So this is like how we are going to proceed.
Okay.
And mm,
Okay.
so this was regarding what would be the procedure, and there are certain rules that we must be ensuring. The presentation time would be 15 minutes, and we will be ringing a buzzer prior to 2 minutes, so they know that they have to wrap up. And even after that they didn't wrap up, we will be providing 30 seconds extension, and after that we will be muting them.
Okay. Okay.
um, a maximum of 5 presenters will be allowed.
Mm-hmm. Just one more request. So we have the mask name, right? I'm not sure if you are aware of it. Will you be calling out the same mask name right now? Because we do not know the actual team names, so that we can score accordingly.
I don't get what you're saying.
So right now, what we have is a list of teams, right? And the names have been masked. So it's like H1 H120.
Okay, like they are coded.
Yeah, they are coded. So will you be calling their coded names?
Yes, like we have to ensure that we don't reveal any IIT name, and if it's revealed, like we will be penalizing them.
Sure, sure, sure.
Sir, if there is any query and all, like you could ask right now.
Okay. So we'll get some initial 10 to 15 minutes to give an intro, Bridgei2i, company intro, right?
Let me ask someone. 1 minute, okay? Yes, sir. Sure, you can give intro and tell about your company.
Okay. So we'll start with the company intro and then we'll kick off with all the presentations.
Okay, sir.
Let me know when we can start, when we have the audience.
Yeah, sure. Hello, sir. Hello.
Hello. Yeah.
Like we also have to read the rules to the participants, so we should do that prior to the introduction or after the introduction.
Let's do it after the introduction.
Okay, sir. So we can start.
Great. Okay. So let me present my screen.
Yeah.
Okay. Can everyone see my screen?
Yes, Jaskar.
Great.
Yes.
Okay, so hi everyone. Good morning. This is Jaskaran. I'm a machine learning AI ML expert in Bridgei2i. I'm working as a manager in the enterprise tech BU for a company. So today, first of all, before we start with all the presentations, I'd like to introduce the company, what we do, and how this entire initiative which we have taken perfectly fits into what we actually do here. Okay, so we are a company of roughly more than 650 people now, and this is a mix of all different data scientists, technology people, business domain experts, and everyone. And currently, we are covering roughly 13 cities, which span across 55 countries now. And we have been working with more than 15 Fortune 500 companies globally. And our presence is right now in US, Netherlands, India, Australia, Singapore. Our primary business runs in US and India, but we do have presence in these countries, and we do have clients in other countries as well. As a unit, we work in four different areas. We work for clients like enterprise tech clients. We work for CPG clients, which are consumer facing clients, and then we also work for banking and financial service clients, and we have insurance clients as well. Over the last more than 9.5 years, we have got a lot of accolades and awards and recognitions as well. And the ones which are mentioned in the right hand side by Gartner are few of them which we got last year. Okay. Now, I'll quickly move on to how this entire initiative is connected to whatever we are doing. So at Bridgei2i, we have a concept called as Scala, where we actually develop the entire skill and try to bring up the next future leader in the analytics industry. And how do we do that? So we have 5 pillars here, where we actually train people. So the first pillar, which is the technical programs, is basically we train people on different technical ideas, technical skills, and so that they can garner those skills and probably deliver better and be successful. Second, which is innovation orbits, which is completely linked with whatever we are doing here in this tech meet, where we actually challenge people with newer problems which are challenging to the entire analytics industry, machine learning, problems which have been never heard of. We try to work on those problems, and we encourage others also to work on those problems. So in this process, we hone more advanced skills in the process. Then we definitely have a lot of clients, and these clients have a lot of problems, and we do projects for them where we try to solve those problems using machine learning, AI, ML, everything. Then definitely once you start working in analytics industry, it's a pretty different industry, right? And when we have to consult people, you need a leader who can help the entire team guide the right path. So we also hone leadership skills inside our company. And definitely, since we are an AI ML company, we have to be on the cutting edge of this industry. So we have an AI labs unit where we actually do research on newer areas, newer aspects of machine learning, AI, computer vision, NLP, you name it, we do that, all those things here. And so we pick up these 5 pillars, and using these 5 pillars, we build data scientists who are a perfect synergy between business domain and algorithm as well. We build AI experts who are sound in all the AI algorithm knowledges as well. And we have technical experts who know the technology better, who can help us advise on those areas as well. And we have domain consultants. Since we are a consulting company, we definitely, no AI ML can live without a domain expert. We always need a domain understanding to help the client or help people or help add value better. And once all these things come together, we get subject matter experts, we get leadership built. And this is where this entire initiative which we have taken up with the IIT also comes into picture, where we are picking up a challenging problem, we are sharing that problem with you, and then we are trying to figure out what is the best way. And we are also trying to learn from you guys as well. What sort of technologies you use, what sort of approaches do you guys use, and this is how we nurture the entire talent as well. And so that's how this entire initiative is perfect synergy for whatever we are doing here. Now, I hope everyone is aware of the problem. If not, then I'll just give you a brief summary. So here the challenge which we had shared was on automating the identification, summarization, and entity-based sentiment analysis of articles and tweets, basically. So we had shared a data of articles and tweets, some 4,000 tweets and 4,000 articles. And these articles were in different languages, 3 different languages: English, Hindi, and English, which is basically Hindi written in English letters, like the text message language. And the task given was to identify which particular article and tweet belongs to mobile tech domain. And if that tweet and article belongs to that mobile tech domain, then identify the brand mentioned in that tweet or article and the corresponding sentiment to the brand as well. And if the article, specifically if the article is a mobile tech article, then also build a 20 word, approximate 20 word summary, a headline basically for that article as well. So this entire data which we have shared, right? Whatever tasks we are doing, these data sets, these tasks are actually used by a lot of marketing professionals to take a lot of business decisions, because based on what kind of brands are being called out in a tweet or in social media, based on whatever sentiments they have, they'll take the right decisions based on that. So that's why this entire case study is actually a problem which we face in the market as well. Okay. Now, so we started this competition on 25th of Feb, and on 21st of March we had a mid March evaluation, and we received some 18 reports, and we had three criteria to evaluate those reports. We had an end-to-end workflow, identifying whether the entire workflow is called out in the report properly, in the right way. That's one criteria. Other was whether the teams have innovated something. We have brought some innovation into the picture and solve the problem. So that's one criteria. And then the last one was scalability, whether the problem can be placed in some other language, or can it be, I mean, is the runtime high, and all those things. So all those things were taken into account when we were computing the scores for mid evaluation. Then definitely we had on 24th, we had the final submission, where we got the final code and all the predictions for the evaluation data as well. And we used these 4 metrics which are called out here to actually measure the performance, and then probably shortlist 10 teams out of those 18 teams. And those 10 teams are presenting today, basically. And today also we'll be looking at these 3 criteria, which is completeness and readiness, as in how ready your whatever solution you have built, how ready is it to be implemented on something, say, different as well, right? Can we pick up that component and then just apply it, right? How ready that solution is. Secondly, what is the degree of innovation involved in how you have built that solution? And last but not least is how structured and how much clarity you have when you're presenting about the problem, about whatever you did, right? How are you doing that? So all those things will come into account. And as called out earlier, it will be a 15 minutes presentation with 5 minutes Q&A. Then, I mean, we got a mid-evaluation report, when we have also the final submission. Some few insights which I would like to share with everyone, so that we understand how much progress we have made here. So on the left-hand side, you definitely see some of the comments which the evaluators have given to some of the reports which we have evaluated. So definitely it looks like we have used a lot of different advanced machine learning and NLP-based techniques here. Which is very encouraging, and is something which we always like to look at. And when we looked at the results, what we saw was the first task, which was identifying a mobile technology, had a very good performance. So most of the teams, right, almost 50% of the teams were scoring more than 90% F1 score, which is very, very good to see. And the teams were lacking a bit when it comes to text summarization. So we had only one team which was crossing the 40% similarity mark when it comes to headlines. I think this is one area where definitely there's huge scope of improvement. Then again, we in the aspect-based sentiment analysis, we divided this into 2 halves. One is brand identification, and then the corresponding sentiment identification as well. So the teams were fairly good in identifying brands. So I would say 6 to 7 teams were able to identify brands with a F1 score of 90%, which is very good. But when it comes to sentiment, I think that's one area where definitely a lot of work needs to go, where only 2 teams were able to cross a 40% benchmark of F1 score. So these are some observations which we have. Overall, I see a lot of positives coming out from this entire initiative. We have a lot of good approaches, innovative approaches, with some sound results as well. So kudos to the entire team here. Then, so now, since this entire thing, I mean, I've called out the case study, I've called out the journey so far. So today, for the presentations, we have the panelists which are listed out here. So we have Ashish Sharma, who is the co-founder and CEO of Bridgei2i. He's an ISI pass out, has experience in GE and Genpact as well. We again have Preetham as well on the call, who is again the co-founder and the CTO for the company, Bridgei2i, and he also has an experience in HP and GE. HP and GE as well. And we again have Joydeep. Joydeep also has more than 10 years of experience in domain of machine learning and AI. And he has worked in different companies from Bank of America to Credit Suisse. And today he's leading today he's the director of algorithm and AI in Bridgei2i. We have Rajni, who is an IIT Madras alumni. She has more than 8 years of experience in AI and machine learning, and right now is a director of service delivery in insurance inside Bridgei2i. We also have Prinkan, who is again having more than 15 years of experience in the field of IT. Currently, he's leading the data engineering and automation unit for Bridgei2i. He's a director of that unit. We have Sombit as well, who is a manager of CPG. He was a manager in CPG unit, and we have Kirti as well, who is again a manager in algorithm and artificial intelligence, and has an experience of more than 7 to 8 years. And he's also an IIT Kharagpur alumni as well. And definitely, I have talked about myself. And we have Akash as well, who is a senior analytics consultant inside the enterprise tech BU, which we have. And he also comes with more than 7 years of experience. And definitely, this entire initiative couldn't have been successful without the collaboration between the Bridgei2i Scala Data Science team and the IIT organizing team. So thank you guys for collaborating with us and making this a success. Thank you. Yeah, that's what I'll have. So I think we can start off with the presentations. We can call out the rules first, Soumya, if you want to do that, and then we can kick off with the presentations.
Okay. Thank you, sir.
Thank you.
So, like we have already made the rule book, but I would be reading out the final rules. So, a maximum of five presenters is allowed to present on the stage. All the presenters of each team will have to raise their hands using the button in the button panel, post which we will invite them on stage to present live. So the presentation round would be of 15 minutes, which will be followed by a Q&A of 5 minutes. And we will be ringing a buzzer 2 minutes prior to the completion of your presentation, post which you are expected to wrap up your presentation in the remaining time. At the end of your allotted time, you will be given a time of 30 seconds to maximum to wrap up, post which you will be expected to stop. The name of IITs shouldn't be disclosed during the presentation and must be strictly adhered to. Any deviation from the same would lead to the penalty of 5% of maximum event points. During the presentation, the succeeding three teams as per the sequence must be prepared with their presentation on the AirMeet platform. And after the completion of presentation of the preceding IIT, we would be waiting for maximum of 5 minutes for the next team, post which a timer will be started, and after the arrival of the team, the time from their presentation will be deducted accordingly. Please maintain a good stable internet connection during the presentation and have proper backup options to avoid any issues. Any use of malpractice, use of foul language, misbehavior, sledging directed against any other team will not be tolerated. In extreme cases, it will also lead to disqualification. So the IIT code number the IIT with code number 11, the participants are expected to raise their hands.
Are we starting?
Sorry, I think there is a confusion here. I think they are reading a different list. We were told we are number 3 on the list. Can we just verify that, please?
Soumya, can you check on the concern raised by the team?
I'm checking once. 1 minute.
So I'm told that there is a confusion between another task where we go number 1.
Uh, like uh, one. Hello. Hello. So, according to the list that we have got, team number 11 is supposed to go first according to the chit picking round.
Is it so? In the group which is formed, we were told we have slot 3.
Okay, just 1 minute.
You're confusing between Bosch and this. That Bosch, that we go number 1. Here I am told we are number 3. The group says team number 12 is set to go take the first slot.
We are sorry for the.
Soumya, do you think it'll be good if you take some? Yeah, do you want to take some time to sort this out? Maybe, I mean, if you need some
Yeah,
10-15 minutes
1 minute.
to sort it out.
There is some confusion. Yeah, so there is a slight confusion. So, 1 minute.
Sure, no worries. No worries.
Hello. Sorry for the confusion. Team ID 12 is supposed to go first. We are really sorry.
No problem. We can start. Uh, let's wait for the judges to come, panelists to come back.
Okay, sir.
Rajni, Jaideep. Okay, I think they're there.
They're back.
We can start.
So should we begin, Soumya?
One more member is supposed to come. Okay, so we can start.
Okay, sure. So good morning, everyone. I am Samarth from Team 12, and I'm going to be presenting on the behalf of Team 12. And we have attempted to solve the Bridgei2i's problem, and it was a really fun statement, and we really enjoyed solving that problem. So let's deep dive into our approach. So first of all, let's have a quick overview of the problem statement. So the problem statement was building an automated system for segregation of text into mobile tech and non-mobile tech. And then after further segregation from the mobile tech text, we were supposed to identify mobile brands associated in the mobile tech articles and tweets. And after that, we were supposed to do the abstract weight sentiment analysis of that brand, that is identify what is the sentiment associated with that particular brand, and then we were supposed to build an automated headline generator for the articles. So that was the basic problem statement. Let's have a quick overview of the data set as well. So the data set consisted of two parts, the tweets and the articles. So there were 4,000 tweets which were in English, Hindi, and as pointed out by Jaskar, in English languages, with 1,000 belonging to mobile tech and 3,000 belonging to non-mobile tech. And one key observation was the data had a lot of duplication, which caused some trouble to us. But again, we handled that carefully. And another observation we made from the tweets by reading a subset of the tweets and having a quick overview of them, that most of the non-mobile tech tweets were actually politically opinionated, where people were expressing their political opinions over Twitters, which is pretty common. And when I read about the articles, it had a similar distribution, 4,000 articles in English, Hindi, and English, with 1,000 belonging to mobile tech and 3,000 belonging to non-mobile tech, with a lot of duplication again. And again, this time, most of the non-mobile tech tweets were articles were actually news articles. So this is something which we'll be using later. So let's talk about our approach. So our main focus was building an end-to-end scalable, lightweight, and innovative approach for identification, summarization, and all the aspect with sentiment analysis we were supposed to do. Our main focus was using lightweight algorithms which could be used in practice and production instead of using just heavy algorithms, heavy word-based algorithm. We were trying to actually make all our models lightweight without compromising on the quality of predictions. Like that is what we are trying to do with our approach. So let's deep dive into a pre-processing pipeline. So the thing is, pre-processing is one of the most important things when it comes to handling text, because like people say, garbage in gives you garbage out. So first you need to clean your data. First you need to make your data really good, really suited for the machine learning model, so that it could actually learn something. So we have spent a lot of time on pre-processing. Like that is something where we spend around 7 to 9 days. So first we did something called language agnostic text cleaning, which is this type of cleaning is independent of language, and this type of cleaning can work with any number of languages. Even if there were like 15 languages on our text, this type of cleaning should be done according to us. So first thing we did was emoji to emoji sentiment conversion, because in tweets people usually express their sentiments through emojis. Like people would use heart emojis, people would use angry emojis, people would use fire emoji. So we did that using a Python library called demoji that converts emoji into its sentiment and appends it to the text in place of the emoji. So that was pretty much helpful for us. Then we removed URLs, RT, which is retweets, QT, which is quote tweets, because most people don't really write something after retweeting and quote tweeting. So they were essentially the same tweet. So we were removing the RTs and QT tags as they were not conveying us any information. We also removed hyperlinks, hashtags, and underscores in the user handles and the tweets and articles as well. And we removed some weird and absurd symbols like a square, arrow, oval-shaped circles like diamonds, chess pieces, and all. We also removed them. Then yeah, coming back to the duplicates thing, as I told you, there was a lot of duplication in the data set. So let me tell you a real life story, like what we did. So after a day or two of cleaning, we actually tried going for classification. So with classification, we were using basic ML model like naive based software SVMs. So we were getting accuracy and F1 scores of like 99%, 99.5% in that range, and we were pretty much shocked and impressed. And we were like, okay, we are winning this competition. But then we realized that there was a lot of duplication in the data set. So the examples our train set was seeing was also in the validation set. So like validation set was not particularly distinct from the train set, and this is called data leakage in machine learning. So there was a lot of data leakage, so we needed to remove duplicates and duplicate like sentences. So we developed a unique graph based clustering algorithm for using Lewis-Tan distance. Lewis-Tan distance is nothing but edit distance, which is commonly used in like dynamic programming. It is a dynamic program problem that finding the edit distance between two strings. So actually, we found the edit distance between the strings and normalized that with the length of the string, and made a threshold after which like we were supposed to say that both the strings are duplicate, and we were appending it to a common graph cluster. And then from a graph cluster, we were picking out only one example, which we were supposed to say that it was unique. And there was a significant decrease in data set after we removed the duplicates. Like we noticed only 40% of the data set had a unique text. So again, like this was something really important. I think everyone should have addressed this. Then we went on for language detection. It's like which language it is. Is it Hindi, English, or English? So detecting pure Hindi was easy because it has like a fixed Unicode character. So like we could always go for Unicode matching. So we didn't require any ML. So we didn't use any ML because if you don't require machine learning, you shouldn't be using it. That is a 100% accurate model right there without using any machine learning. Then we went on for detecting English. So we built a character level bidirectional LSTM model, which was trained on a self-made dataset, which were annotated by us to a limit, and like we combined some of the data sets as well. And it was able to identify English from English text with up to 95% accuracy. This was a word-by-word model. So again, some words are pretty controversial in English, and even humans have some problems. Like the word is samay. So the word is, it could be an English word is as well, and it could be a Hindi word is. So again, like these kind of controversies can lead to decrease in accuracy. So that's why we were able to reach up to 95 only. Then we were transliterating the Hindi text. So transliterating essentially means converting the text into its native language. So the English was converted, which is English is actually the code mix. So it was transliterated into Hindi. So if there was any English text, like it wasn't there, but we would have converted into Tamil and so on. So we used some publicly available data sets, and we cleaned them a bit. Like there was some noise. There was some noise. The model we applied was a 4-layer vanilla transformer. It was a totally new model we made, and we have also developed a Python package for this model. Like we have made it in production. All the things we are doing over here, we have tried to make it scalable and production ready. Like that is our aim for this problem. Like instead of using heavyweight BERT based model, just we are making good scalable things which can be used. So we compared it with the Google Transliterate API. So our score was 50.4, Google's score was 53. That was the blue score. Again, Google was better, but our model was 2.2 times faster. So I think like we should be preferring our model over here, because 2.2 times boost in speed is pretty impressive according to me. Then we translated Hindi. Like we were translating Hindi to English, and for that we used a library called MarianMT. So MarianMT is basically built by Microsoft, and it is built on C++. So it's a very fast and robust library because it is built on C++, and it has got 1,000 plus pre-trained models. So it is pretty scalable. Like it has got a good support. So if someone has already done something, like we shouldn't be implementing it from scratch. Like that's what I believe in. And it's a fast library, and it can run on multi support as well. So for big organizations like Bridgei2i, if you have got a good GPU cluster, you can run MarianMT on GPU support as well. So this thing would make it really, really fast and robust. And the thing is, now as we are converting everything into English, so basically if there's a problem of scalability, like multiple languages coming into play, so we are going to do a very basic thing. We are going to either transliterate it into the base form and then translate it, or if it's in the base form already, we are going to make it English and then use some pre-processing pipeline on English. So basically, for any new type of languages, we have to follow just 2 simple steps, which can be done very easily. And like we have got translation. For the translation, we have got a library, and for transliteration, we have developed a library. So the obstacles we faced were like transformers are pretty expensive. Like they have got O of n square as a complexity, where n is the sentence length. So we were trying to make linear transformers, which is called linformers. We did try them, but they weren't giving us proper accuracy, and accuracy was obviously the objective. There were noisy data sets, like the data sets were annotated by public, so they were public data sets, and like public annotation was done. So again, the data sets were pretty noisy because public is not really good at annotating the data sets. So a huge part of cleaning effort is required in this, and we are looking forward to that, but like in a smarter way. Then we were pre-processing the English text. So in the English text, we were first cleaning the contractions, because when we use English text, we use vocabulary. So can't or cannot and cannot are not two different words. Like we as human beings know that, but the machine does not know it. So they will label it differently. So they will make a different word for can't, different word for cannot. So we never want that. And for the similar reason, we were converting British English into American English, because word color has got two spellings and it means the same things. We were also removing the punctuations because punctuations weren't really affecting us. But yeah, we did think of keeping the punctuations, but that didn't really help in the model. But yeah, so removing the punctuations were essentially removing the noise. And we were getting rid of stop words as well, like a and the, which were available in NLTK. We also used lemmatization, which converts word into its base form. Like pre-processing can be converted to word pre-process from NLTK. So we would like to make transformers cheaper, and we would also like to establish multilingual support for all models and libraries. Let's move on to mobile tech classification. So the aim of this module was to automate the task of filtering out articles and tweets which belong to mobile tech category. So again, the data set that was given was used, and we scraped almost around 3,000 tweets from a mobile tech library called Bridgei2i, which in that we were supposed to give brand names as queries, and the similar data for articles was streamed from this website called gadget.ndtv.com/mobiles. For non-mobile tech classifications, we use two datasets from Kaggle, one being demonetization tweets and other being a news article dataset. Why we use them? Because again, I told you the tweets were politically opinionated and the demonetization tweets are similar. So I was trying to match the distribution, and the news article dataset is pretty obvious because the articles which were non-mobile tech were mostly news. So the validation strategy we employed was this is pretty common in industry. Like in my intern, I have employed the same validation strategy, and it has really helped me a lot. So 80% of the data set was added to the new data set, and the remaining 20% of the data set provided by you was our main cross validation set. And further, we also made a secondary cross validation set from the 10% of the new training data sets, so we can address both bias variance and the data distribution mismatch. We used a two-layered BiLSTM with 100-dimensional glove embeddings for mobile tech classifications of articles and tweets. That performed out pretty well. The training F1 we were getting was 0.968. The primary validation F1 we were getting was like 0.942. The secondary validation was 0.959. The testing F1 was 0.92, which was provided to you by you. And this was the second highest score according in the leaderboard. So I think that was pretty well for us without using any form of transformer. This gap is training between training and secondary is due to variance. How did other models do? So we tried other models as well. Knife-based SVM, they performed really bad. Heuristic-based dictionary search was also bad. It was a non-ML approach, but it was still bad. RNNs weren't performing really good. So BERT, both of the BERTs were performing similar to my model. So I didn't go for BERT because again, lightweight approaches are more preferable. Future prospects, like as Jaskaran mentioned, we could use the knowledge of subject matter experts and encode them into the machine learning to make it perform better. And we could also work on collecting better data. So again, let's move on to task of brand identification, where we were supposed to identify the brand, and we used a non-machine learning based approach, and honestly, like that gave us the best score on the leaderboard. So the thing is, we used dictionary based regex search, and we were updating the dictionary regularly from the website. And this was simple and super light approach that was also reliable, and we also included for common spelling mistakes as well. So the results and validation set were 0.97 and the test set were 0.94, which was highest. Other things we tried were named identity recognition, but it didn't work so much. Fuzzy string matching was giving us a lot of false positives, so that led to a decrease in F1 score. For sentiment analysis, we used a graph-based clustering algorithm, and the dataset was a pretty standard dataset called Lab 14, along with our scraped dataset. So actually we were using a grass convolution network over a bidirectional LSTM. So that network was giving us attention scores, and that attention scores were actually leading to the final representation of the sentence. And that was basically finding out the long-term syntactic dependencies of the brand with the sentence. So that helped us a lot, and that also gave us a good score. Like train F1 was 0.90, primary validation was 0.65, secondary validation was 0.67, and test F1 was again the highest on the leaderboard, which is 0.48. So again, that result helped us a lot. For headline generation, we used a model called T5. Like T5 is a pretty great language model. Like T5 is one of the most novel language models I've ever seen, and we were using this because it is pretty much preferred in every kind of language modeling test, but that didn't perform out so well. But again, T5 was lighter than BERT because T5 had 65 million parameters. So again, lightweight approach, more scalable. So again, it was lighter model, so we focused on that. But yeah, so I realized our test score was pretty low, like it was 0.27. So again, we are going to reiterate and work on better models and using a larger beam search and find out a better model for this thing. So like we have a scope of improvement in summarization, and we would like to surely work on this with you. This was how we worked. We spent most of our time in pre-processing and classification. Brand
Our
identification
time
was
is
done
up. You
like
are supposed to wrap in 30 seconds.
sure. So brand identification, and this is how we work. Like this is our basic timeline of working. Thanks a lot. Thanks a lot for listening, and we would love to have some feedback and work further on the problem. Again, thank you.
So now the judges will ask question. So the Q&A round will follow.
Okay. So definitely, I mean, very well explained presentation, no doubt. One doubt which I had was on how you converted the English words or letters into English. So here, did a token based transformation, or did an entire sentence transformation? Basically, did you convert one word from English to English, or did you convert the entire sentence at one go into English? I think
Seems
back.
he's lost connection. Can
Yeah.
anyone of any other team members pitch in on this question?
Yeah, like if any member from the team who is not present here can raise hand.
Hello, am I audible?
Yes, yes.
Yes, sorry, there's a net connection issue. So Samarth will take on in my laptop.
Okay.
Yeah, just a minute. Give me a second. I will. Yeah. Can you hear me, Jaskar?
Yes, we can hear.
Yeah, I'm really sorry for the internet issue. Like it just happened in our campus. So yeah, so actually we were using the word-based conversion approaches. Like every word was converted, transliterated from English to Hindi. So that is what we were using instead of sentences. So, did you get
Okay,
that?
so how did you ensure that the context of a word is picked up from the sentence? Because you don't want to convert a word just based on solely that word, right? You want to look at the context where that word is sitting inside the sentence and then convert it. How did you ensure that happens?
Yeah, so we weren't actually able to ensure that happens because we've also tried sentence-based approaches, but as I mentioned, that is why we were making errors on that. That was the reason that we were losing some of our accuracy in that. But yeah, given more time, we would actually like to work on it and make sure that this works.
Okay. And one more question. You told us that you have used a technique called lemmatization, correct? For
Yep.
pre-processing. Okay.
Yep.
I hope you're already aware that lemmatization itself is a pretty technique, as in it actually impacts heavily on your runtime. And on top of that, you have also used an embedding based techniques to classify. Do you think it's beneficial to do lemmatization when you're already using word embeddings? Right? I mean, word embeddings can already help you in finding out similar words, right?
Yeah, word embeddings can help us in finding out similar things. That's why we were using like state of the art embeddings called Glove. So again, like,
Yeah.
so the lemmatization thing was actually like decreasing the vocabulary size. So like I thought, I assumed that would help, and that gave us like not a significant but a small boost in the accuracy.
That might be
That
due to
might be due to
random
random
thing,
thing,
but
but
still,
still,
like,
like, because
because
that
that
gave us
gave us
a
a
boost in
boost in
accuracy, so
accuracy,
we
so we
went for
went for
that.
that.
But yeah, again,
But yeah, again,
lemmatization can be removed
lemmatization.
from the pipeline if we are actually going for production. Like I actually wrote the function in which there's a definition in which I can provide arguments for lemmatization stopwords, and also I was actually playing along with that. So again, like I could keep the lemmatization parameter to be false, or I could choose changes to be like to be for the users as well. Like user can specify, do we need to lemmatize or not?
Okay. Since you have done lemmatization, do you think the challenge in identifying the brand names? I mean, say like a word called care can become car, right? Then how will you identify that brand? And
No.
you have already, I think, used a dictionary to identify brands, if I'm not wrong.
Yep. So actually, while using lemmatization, we were masking out the particular words, like using the dictionary. So like those words were not supposed to be lemmatized; those were masked.
Okay. How did you know that beforehand?
Like again, we scraped the data of all the brands, right? Because that's how we are using the dictionary based approach. So while lemmatization, we were actually removing those brands from the sentences. Like if there's this brand, mask this out, and then do the lemmatization, and then impute this brand again. Like simple.
Okay. Okay. Got it. And what's the runtime of each of your modules? Can you just tell us that? That will be useful.
Like we don't really have the exact runtime because it was actually like we were training on 2080 Ti. So the so like the runtime for a particular module was like we don't really have the exact runtime stored for everything. Like
Okay. What about the overall runtime?
yeah, so the overall runtime I can tell you, like for the overall, like when I was going for classification thing,
Uh-huh.
so the overall thing was running on 0.1 second, like overall on that 4,000 tweets and articles.
So this is scoring on 4,000 tweets and articles, right?
Yep.
Okay, so 4,000 is 1 second, 1 point,
Point one, point one, point one,
point,
point one.
point 1 second. Okay, and what about the other modules? Uh,
And
then
for the other module, yeah,
yeah,
and for the other modules, yeah, so the brand identification was pretty fast. Like it was using the regex based method, so it was and it was only on those thousand data points. So it was pretty much around like 0.005 005.
okay. Sentiment.
And yeah, so the sentiment was a heavier model which we were using. So the sentiment was taking us a lot of time, but again we were using that on only 1,000, like because we had only 1,000 mobile tech. So again on that the sentiment was actually again it was somewhere near around 0.2, 0.3, like it was somewhere fluctuating between that.
Okay, summarizer.
Yeah, summarization was again heavy, so it was going for around 0.4, 0.5.
Okay, thank you. I'm good, Joydeep and Rajat. You guys can ask.
I had one
If
question,
you have.
very quick question, guys. Can you all hear me?
Yep, we can hear you.
Great, Amrit. So you use ensemble in language detection, right?
In language detection, actually, I didn't ensemble anything. I used different model for Hindi.
Understood. And you're combining the results of all three different models, or is just one result that you are considering? I think it's dictionary
So
based,
basically, I
LSTM,
used
different.
yeah. So basically, Unicode matching was used for detecting Hindi only. So once we have detected all the Hindi, we can take out the Hindi tweets and articles from the data sets. The remaining is of English and English, right? So then I was using another model to identify English texts. So like now I have English text as well. So now I've segregated all three texts.
Understood. Understood. Thank you so much.
Welcome, Rajni.
One question, Bhavnik. I think while Samarth was presenting, he showed that your team used some technique to understand the meanings of emojis, and I think it was mentioned you used something called Demoji.
Yep.
Can you just talk about that a bit more and let us know as to how that is working and how reliable is that? How can just take us through that a bit if you can.
Okay, so basically, Demoji is a Python package, so which converts emoji into the text relevant to its emoji. So basically, again, it is not really machine learning approach. It was actually annotated by people. So like this emoji represents this kind of mood. So like people have annotated that, and they have built a library on top of that, and we have used that library because. So suppose like so the thing is, if someone sends a fire emoji or a heart emoji, so it changes the word that emoji into that particular message, like what they are trying to portray from that. So that kind of helps us in making out a sentiment out of that, because if someone is happy, it's going to send hearts, like that is something common, or likes.
So, for example, I think one thing that might be a little confusing might be a fire emoji. So, what happens in a fire emoji situation? What does it translate it into?
Okay, so the fire emoji translates into it basically translates into fire as fire right now because like the emoji translates fire, but yeah, like that does look like a promising area to work on, translating emoji into the sentiments they convey.
Got you. Okay, thanks. I guess that's all in terms of questions possibly from our end.
Okay, sir. Thank you. So I will be calling the next team. So we will be having a 5 minute buffer time.
Thanks a lot, everyone.
Many thanks, guys.
Love.
I guess everyone from the team is present here, so we can start the presentation.
Sure.
Sure, Soumya.
Just, is everyone being able to see the screen? Hello.
Yes, we can see it. Yes, we can see you.
So I'll start. So hello everyone. So I'm Aman Kansal, and I'd be presenting today on behalf of the headline and sentiment generation team from IT number 9. So this is the control flow that I'll be following. So first of all, I'll take you through our system architecture, and then I'll be talking about all the details about the pre-processing and each of the subtasks. So here we have the overview of our system architecture. So we have as input the articles and tweets, and then after a pre-processing step, it is fed to a classification model. The details again, which I'll be talking, which classifies the articles as either belonging to tech category or non-tech category. So if the documents are classified as to be in tech category, then we have two modules. So one is the headline generation module. So it directly takes up the article classified as tech and it spits out a headline for that. An important thing to note is that our headline generation module is not at all conditioned or dependent upon the brand identification module or the sentiment classification module. Brand identification module again in turn takes the article and tweet from the those classes tech and it feeds them to the sentiment classification module as pairs of the brand that it identified and the sentence in which that brand occurred. So the rationale behind that I'll be explaining in that section. And finally, we have the brands for each of the sentiments and brands for the articles as well as the tweets. So I'd be starting with the pre-processing step. So our pre-processing was directly inspired from the kind of data that we had. So we had online sources, that is the tweets and articles online. So we removed things like at the rates, hashtags, and also punctuation marks, of course. And also we removed the phone numbers and the URLs that were there. Those were not useful for classification. And finally, we lemmatized the text only for those approaches where we needed to use the deep learning techniques down the line. So starting with the subtask 1 of domain classification, that is classifying whether or not the article is tech or non-tech. So here what we observed was that a bag of words approach was not only more efficient and scalable, but also gave us better accuracies and numbers as compared to a proper deep learning approach. So we had a bag of words like the company name, Samsung, MediaTek, BlackBerry, and also some generic names like smartphone, camera, earphones, things like that. And what we used was not an exact string match, but a fuzzy, or you can say an approximate string match based on Levenshtein distance, so as to factor in any spelling mistakes that were there. For example, if since these are online sources, it's very likely that the person typing them might make a spelling error because it's people usually type on phone, so that's very common. So to factor in those things, we use an approximate string match with a high threshold, though, so as to not have many false positives or false negatives, but in fact do the accurate job of classification. So this is the approach that we followed for task 1. Now, the bag of words that we had were classified into 4 categories. We had generic words, we have brand names, we had specifications. For example, if something like gigabyte or RAM is occurring inside the text, then certainly that's related to a tech category. And finally, we had accessories like earphone and headphone. Now moving on to the second task, where we had to classify, where we had to identify the brand from the text given and also classify the sentiment. So here again, we refrain from using a deep learning model. The following were the three main reasons. First of all, the data had a lot of cross-linguality and transliteration. So if we use any model that was pre-trained on such a task, that always has a suboptimal performance. Those type of models are not studied as well in the literature. So we did not want to bottleneck the performances of a model at such an early stage. Also, the articles at least were very large, and in a resource constrained environment, it doesn't make sense to have so much high runtime and memory usage if we use a deep learning approach. So if we were getting better numbers, better metrics with a non deep learning approach, then we followed that. And finally, it's important to note that the set of companies that we have to pick are finite as well as very large. So such a large but finite set is not very well leveraged by any neural end-to-end model. So these are the three reasons why we refrain from using a deep learning model. What we instead did was again a rule-based approach where we had a bag of companies which we picked up from online sources, and then we converted those companies to their Hindi counterparts. And how we did that was the Google Trans API. So what's special about this API is that it is one of the only APIs that does a very good task of converting named entities into their Hindi counterparts. So so if you want something like techno, then you want the Hindi form of techno, and not you don't want the Hindi form of technology. So that's what Google Trans handles very well. So using starting with the English bag of words and adding the Hindi words to that set, we again did an approximate string match. So the approximate string match here again counters if there are any spelling mistakes, even done by the Google Trans API. Then also we have some breathing space, and that's handled by the approximate string match, which again uses the Levenshtein distance internally. And once we have identified all the important companies that are there, or not important, but all the companies that are there in the text, then we feed it sentence by sentence to the classification model, to the sentiment classification model. So, for example, if we identified the brand name Apple, then we pick up the sentence Apple smartphones are expensive, and then we feed it to a classification model, a embedded classifier model, and which does the sentiment classification in a target agnostic way. So, for example, here we have the sentiment for Apple as negative. Again, we pick up another token, iPhone. The company is again Apple, so we pick again Apple, and Apple now has two negatives. So it's important to know that if a company occurs many times in a text, it's possible that various different sentiments are associated with that particular company. So in that case, we just pick the sentiment which occurs the most number of times. And here, finally, we have OnePlus, and the sentiment there is neutral. So yeah, for Apple, we output negative, and for OnePlus, it's neutral for this particular example. And now I'd be telling you about some of the intricacies of this approach that we faced. So first of all, we use MBERT model. So MBERT model is a very scalable model because you can input to MBERT any of the 104 languages that are there, and you need not retrain the model according to the language that you're using. So even if the model is trained on English and Hindi, the MBERT model handles it internally to not need any retraining. So MBERT model is highly scalable over languages. And another important thing to note here is that we were feeding only tokenized sentences to the MBERT model and not the whole articles and tweets. So articles are very large. So if you feed such a large text to a deep learning model, then obviously that has a lot of latency as well as memory requirements. And what we found out was that feeding only sentences, tokenized sentences, like sentences tokenized from the whole articles, was not only better in terms of latency and memory, but it was also giving us better accuracies. Moreover, if you follow such a tokenized approach, then you can use the combined data from article as well as tweets to train a single model. So for a single model, you have more amount of data that you can use to train that model. And moreover, if you anyway use the different models for articles and tweets, then that's an added memory usage. So yeah, so we tried to be resource efficient at the same time improving our accuracies in this approach. Also, we pre-trained, apart from the dataset that was given to us by Bridgei2i, we also pre-trained our model on Semival, and also its translated counterpart. Its counterpart translated to Hindi. So just to make the model more robust. So concluding this, and then I'll move to the third subtask of headline generation. So for the task of headline generation, I added so we added another pre-processing step where we converted all the text that we had from articles to English. We used the Translate API for that. So the good thing about Translate API is that you need not specify the input language, the source language from which you want the translation. So that means the model that we have rolled out currently is already scalable across all the languages that are there. And in the backend, the Translate API uses a multiplex of various translation servers, which are from like Google, Microsoft, Baidu, and all those tech giants. So the translations are also pretty accurate. So once you have the translated articles, then before telling you about the approach, it's important to see the data distribution here. So it's in terms of the number of words that are there in the article and the number of words that are there in the headline. So as you can see, the headline we were constrained to output max 20 words, but the articles could have been of arbitrary length. So the compression ratio, first of all, was very high. Moreover, if we use any out-of-the-box summarization model, then usually those summarization models have the pattern that the output summary or headline is always proportional in length to the articles that you have, to the input text that you have, and that distribution was not at all there. That distribution was not replicated in the data given to us. So it's important to fix that distribution issue before we before we train on the data given to us. And how we handled that was using the XM dataset or the extreme summarization dataset. So XM dataset has the following pattern. So for every article that you have in XM, the headline that the output it gives is the answer to the following question: what is the article about? Now, this may not be exactly the headline. It's slightly different, but in terms of data distribution, so even for a large article, the output of what is the article about will still be this. So that data distribution is replicated here, and even the data itself. For example, we in Bridgei2i article we have, let us say, article length of 603, and the headline length was of 16. So even for XM, the articles are quite large, like 431 words, and the headlines were still in range. We were constrained to 20, but still 23 is good for pre-training. So we use the models which were pre-trained on XM and not directly the summarization models that we had. And another insight that we had in this approach was that we did not throw away those articles that were classified as non-mobile tech in the first step. Why we did that? Because they were not completely useless. So though they don't teach you to output words of that particular domain, they still teach you how to adapt to the task, how to achieve that large compression ratio, and how to achieve that data distribution. So we found that using even non-mobile tech articles as training in this task improved our metrics as compared to using only the tech classified articles. And obviously there are those tech classified articles as well, and that they do teach you how to output words corresponding to that particular domain. And yeah, as I said, that we get better metrics with using both these data sets and not just one of them. And finally, coming to the model that we use, so BART is a very generic and very widespread model that is used for such kind of tasks. But there's again a catch. So BART is a very complex model, and it has a humongous number of parameters. So and the data that we had for training in our last task, that is the data from Bridgei2i, it's quite small. So if we use BART to train on such a data set, that will mean that the model overlearns, like it crams up everything, it crams up the data set, which we don't want. We wanted to learn the pattern. So for that, we used a lighter version of BART, a distilled version of BART, which is called the distill BART. So and using distill BART, we not only observed like the parameters were low, and hence the training time as well as the inference time and the space required was low, but also the Roche scores were better for distill BART as compared to BART. So yeah, execution was verified with the experiments. That was the approaches that we followed for all of the tasks. Now, I'd like to conclude with saying that through all the approaches, we tried to pick up the simplest approach that will give us the best numbers, and we try to innovate in that way. Also, all the models that we had are totally scalable across languages. So, regardless of the input language, our models can work. And finally, we always try to minimize the resource through all our subtasks while not compromising in terms of accuracy and metrics. So for task 1 and part 1 of task 2, we did not use any deep learning models at all. So that's already very efficient and memory, and low on memory. But even where we use Ambert, there also we were not feeding the whole article. We were just feeding it sentences, which saves a lot of resources. And finally, instead of blindly using a model like BART, we tried to find us a model which was of lower size, lesser size and lesser complexity, which is the distal BART, and we found that it even did better. So we were quite happy that we had a win-win situation over resources as well as metrics, and that's for the pitch. And I would really like to thank you on behalf of the whole team to give us the opportunity to work on this problem and learn for it. And the whole team is now open for questions. Thank you so much.
Thank you, Aman. So now the Q&A round will begin. Judges, you can ask question.
So I can go first. Thank you, Aman. Just checking, can you hear me?
Yes, I can hear you.
Audible?
Yes. Yes, ma'am.
Perfect. So, you using something like a context detection. So, if there is a brand name that is given and there is some generic word related to iPhone, you type in the context saying that this phone is now talking about the brand sentence. So, my question to you is that brand retention or the context retention, is it unidirectional, bidirectional, and what will happen to a scenario where there is a phone word written and it is followed by two different brand names? So that word for a phone will be given to which brand? It's the first, let's say Apple brand, and the next sentence, let's say Sony brand. Do you understand my question?
Ma'am, can you please repeat some part of can you please repeat the question? I think there was some network issue in between, so it would be helpful.
Sure. Can you hear me all right now?
Yes, ma'am.
Okay, so let me try again. So in your sentence tokenization, I think you are doing a context retention, right? The context retention is what I mean is there is a first sentence which mentions brand name Apple. Then the second sentence which basically says something about only phone. Then you're saying that since this sentence is followed by Apple, this phone word or whatever sentences, it's talking about that Apple brand itself, right? My question to you is, your context retention is unidirectional, bidirectional, and how do you manage a scenario where the word phone is present with an Apple sentence and with a Sony sentence? So where do you assign the word phone to?
Okay, I understood the question. So let me answer that. So the approach that we are following here is that we are keeping a context of sentences around. So let us say there is a sentence which mentions Apple, and followed by there's a sentence which mentions phone, and following that there's a sentence that mentions there is a sentence that mentions maybe Nokia, right? And now the phone sentence might be associated with both either Apple or Nokia. So we keep that particular context alive. We don't miss it out, and we allow the since we are using a BERT model. So BERT model is the context in MBERT it is, but still the BERT. So MBERT model handles context internally. So it's a bidirectional context. It's a self-attention approach. So the context is obviously bidirectional, and it's already known that the BERT models can handle such tasks of entity resolution or entity linking inside the text implicitly. So so ideally there is no need for us to handle that directly, and we just left that to the deep learning model that was there and enhanced.
Sure. So there was no other extra step taken by you. It just based on your understanding, MBird would have handled this. Am I right?
Embed would have handled this. And another insight here is that I won't say usually, like from our inspection in all of the cases, the any sentence that talks about a tech always talks about the company that precedes that. So an approach where we also tried that approach. And yeah, so that's why we minimize the context. So we started with a large context initially, but we minimized the context to two, because that was enough. A sentence following that always talks about the company that was mentioned just before it. So a context of size two, like that is just the sentence after, is also good enough. Thank you so much.
Thank you so much.
Go ahead, Joydeep.
Okay, sure. Thanks, Jaskar. So I think Aman, I think one thing you mentioned, I not sure if I picked it up rightly, is that your approach of handling language scalability was to translate everything first and then apply your models on the translated data. Did I get that part right?
That's partially correct, sir. So for in the subtask 2, we use an Ambert model. So Ambert model does not require any translation in itself. So Ambert
Sure.
model can be directly it's cross-lingual in itself. So for that, there was no need of translation. But for other tasks such as task 1 or even subtask 3, yes, we did translate the article, and uh, that's how the language scalability was handled. That's true.
And do you have any sense, or can you share us any observation that you have had in terms of the accuracy that you saw for English language data as opposed to Hindi language data post the translation? I mean, does it impact it in some manner that you have observed or anything like that?
Okay, I don't think that we have the metrics right now. Anyone from the team can speak of if somebody knows anything about it. But
Okay.
like the
Yes.
Yeah. So for task one, there wasn't really any difference because we were using both in the bag of words, both Hindi and English words are used. So there wasn't any need for a separate translation in that. But for task three, I think, yes.
right.
Yeah. So for task 3, we were translating it to English language because the headline generation has been has been worked upon mostly on English language. So there was no available models for to work upon, and not much available data to work upon other languages. So that's why we thought, and quite naturally, it was the first instinct to translate all the articles in a single language, English, and then work upon headline generation. So the library we have used actually supports 104 languages, which also supported by Ambert. So the model that the task 3 pipeline we have given already scales up to 104 languages.
I'd just like to add something on that, sir. So, in all the in all the solutions that we had, we always had an almost equal representation in terms of training data of English as well as Hindi. So, for example, we had Semeval. We translated Semeval to Hindi also, and then we had Semeval Hindi version as well. And even whenever we had bag of words, we had all the English words as well as their Hindi counterparts. So in none of the approaches is there any weight difference in as compared to Hindi and English, and even the data that was given to us was quite balanced in terms of languages. So there's no reason to believe, for us, there is no reason to believe that there should be any difference in accuracies over Hindi or English or any other language for that matter.
Got you. Thanks for the answer. Thank you.
So just extending to what Joydeep was asked, an extension question. So basically, you handled English and Hindi, but what about English? How did you handle that? Because that's not being called out in any of your slides or presentation. How did you handle that?
So yeah, actually three English or even translated Hindi words, they were also converted into English language. The library handles automatically detects the input language, even the translated Hindi words and even the English sentences, and converts them to English words. So, Aman, if you can go back to slide three, it's
Sure.
there. Yeah.
Slide 3, you said?
It's not the task three.
Okay, task 3.
Yeah, there. So even in the English translated Hindi articles, all were converted to language, and then we were worked upon headline generation.
Yeah, and
And
in
how
task one, we didn't need to take care of transliteration because we only used the bag of words and it had both in English script and in the Hindi script. So English wasn't even needed. English anyway would go with either one of them.
Okay. So one issue, like say suppose there's a tweet called I love eating apples, right? That's a tweet. An apple here is a fruit, but when you do a bag of word technique, you detect apple as a keyword, and apple has already been a brand for you, right? So your model will tend to classify that tweet as a mobile tech tweet, even though I was just talking about a fruit. How do you ensure, say, even if you use a bag of word technique, how do you ensure that such scenarios don't pop up?
That's the right question. So the thing is that like we initially started with only some very generic words like smartphones and accessory words, and only for handling some of the corner cases we added some company names, and we added very few company names. So not the set as large as we did in task 2, and this is a concern that we recognized early on, that if a company name matches a real life entity, then that would be an issue. So we just tried by adding those company names that had no real world entity relevance. For example, we don't want to add Apple, obviously, and we don't want to add, let us say, Intel, yeah, because Intel and intellect. So these things can match. Although the threshold of the approximate string match would be high enough to prevent this, but yeah, we refrained ourselves from adding such kind of words to that. And the word set for task one was self-designed, and we were already getting accuracies like without even, yeah, using only a very small data set and observing the words from that and picking out very generic words, very small set of words. We were already having 95% plus accuracies, and that is without any train or test overlap. Yeah, without any data leakage, we were getting those accuracies. So we added only a very few specific company names, and that's it. Nothing more than that.
Okay, got
And adding to that, we use this bag of word method because for the given that was made available to us to analyze, we found that the way the annotations are being done, it was clear that the data generation process itself was following some kind of string matching with a bag of words. So that is why we felt that if the larger data set from which this data set has been sampled, the data generation process of the larger data set, if it reflects the same probability distribution, we can actually get that classification accuracy high if we just use a simple bag of words method. If we had
got
found that would need much bigger contextual information for classification, we could easily go for a complex language model. But for this particular data set, when we analyzed it, we didn't feel the need to go for it.
got it. Yeah, I think we are done. Don't have any other questions.
Okay, so
Okay.
thank you
Thank you
everyone.
so much. Thank you so much,
Thank
ma'am.
you.
So we will be moving to next team. So the participant of team 11, please raise your hand. Uh,
Hi, Soumya.
yeah.
Soumya, is it possible to add Glenn also?
But we have to reduce the team size for the participating team. Okay, sir. Give me a minute.
Wait, can we swap Glenn with Akash right now?
Yeah.
Is that
Yes, sir.
possible? Thank you. Yeah. And once that is done, we can get started.
So I have to call Glenn, sir. Hello.
Yes, Glenn. I think he's there.
Okay.
Glenn Lobo. Yeah. And the panelists remain the same: Joydeep, me, and Raghu. We just have Glenn as an addition. Yeah.
So, sir, can I call the team?
Sure, definitely. We can start.
Hey Soumya, you can add Preetham as a speaker.
Yes, sir.
Preetham Kantipal.
Mr. Preetham, you have to raise your hand so I can give you the hand mic.
I've done.
Yes, Soumya, we are good to go.
We can start, Soumya.
Yes, sir. I'm inviting participant to the stage.
Can I confirm if my screen is visible?
Okay, you can start now.
Yes.
Hello, everyone. So I'm here with my team. We are from Team 11, and this is our proposed solution for the automatic headline and sentiment generation task. So the entire task is split into three sub problems. One is theme identification, then is headline generation for mobile tech articles, and then for the same mobile tech articles, we identify entities and assign a sentiment for each of them. So this is our entire solution. So what we do is, given any text, we perform some sort of pre-processing on it. Then we take a phoneme-based Kim-CNN variant to classify whether the given text is of mobile tech or non-mobile tech. If it is of mobile tech, we generate headlines using an MBART model. And this headline, or if the text is short, this is directly passed on to an NER-based model, which identify entities and assign sentiment as well. So the final outcome of this entire model is to generate headlines, classify text as whether mobile tech or not, and also identify brand entities and assign a sentiment to each of them. This is a pre-processing pipeline. Um, we first we do word expansion. By word expansion, I mean we convert RN to R not, didn't to did not, etc. Then we perform some basic cleaning, like we remove tags, we remove mentions, we remove hyperlinks, HTML tags, we remove hashtags, but we retain the text. Also, we remove some kind of entities which are available, which are present in tweets, like retweets, quote tweets, etc. Then we remove emojis, and finally we remove stopwords with some probability. The reason why we are removing stopwords only with some probability is because sometimes for the tasks like headline generation, it is important to maintain the coherence in the text, because these are connecting words generally, these stopwords, and it's good to have some sort of coherence between the words themselves. Therefore, we don't remove all the stopwords, but with some chance we remove the stopwords. We shall now describe the rest of each of these solutions individually.
In the first subtask of theme identification using text classification, we are using the concept of phonemes. We have adopted the idea of phoneme-based architecture as a model. The central idea of phonemes is that it is a basic representation of any language, and it is the smallest unit of distinct sound. Being a unified representation across multi-languages, it is a perfect fit for multilingual classification. Furthermore, International Phonetic Alphabet is a dictionary which converts any languages to a particular phoneme structure, like the one shown below. In this example, it contains a mixture of Hindi and English. Still, the phoneme conversion converts it into a unified structure. Take the case of two words, pad and pat, with a D and a T. These words can be separately written in phoneme language, as D and T have a different phoneme representation, and it shows how we can distinguish words based on sound. Furthermore, the driving force behind this is the very fact that phonemes have a very small vocab size, and to put things into perspective, for this use case, for Hindi, English and English language, we only need 98 phones to train the whole model. Whereas if we had used any words to system, we would have used some thousands of words to have the whole vocabulary. So this reduction in size is very important for our model to train faster. Further, to move in our endeavor to reduce inference time and minimizing the complexity while retaining accuracy, we use a 3-layer kin-CNN network. This model is widely used in NLP structure, and we have used a kernel size of 7, 9, and 11 for further enhancing our results. Next slide. To counter the issue of low variance data, we had to augment the data. Basic augmentation methods like synonym replacement didn't have a huge impact. So we'd introduce a novel idea of latent mix in the intermediary layer. In this mixing, we sample a batch and we mix a sampled batch and the actual batch with a lambda parameter. While in labels, we compute cross entropy individually for both the batches. This helped us to introduce variance in data and made the model to capture deeper context, a deeper understanding of the model. The idea behind latent mixing is that it helps in capturing more fine-grained info instead of high-level features. And this helped us to introduce variance in the data. Lastly, a sequence length of 550 phonemes were chosen for theme classification, and it took only 25 to 30 epochs to train the model completely. To achieve a baseline so we can compare our kin-CNN model with the other models available, we use a pre-trained XLM Roberta model and fine-tune using specific domain training strategies which people use in the community. We can note over here that our task is a subdomain task. We have to classify whether the genre is mobile tech or not. While XLM models have a very high tendency to generalize beyond that, they tend to classify multiple tweets or articles which lie in the technology domain into mobile genre. And and you can see in a couple of examples mentioned below how our phoneme-based CNN model does not fail in that. Also, one powerful advantage of a kin-CNN model over XLM and Roberta model is its compute speed. It's of an order of magnitude faster compared to XLMRL, and it's 500 times smaller than XLMRL. The most important part over here is this model is at the start of the pipeline. As a result, it's going to be hit with a large number of gigabytes of text data. Therefore, having a very low inference speed is the key to over here to not cluster our model or slow down the future models in pipeline. Next slide. Yeah, these are a couple of results. One can see here, because of adding our latent mixing feature in the kin-CNN architecture, we have sort of achieved a compatible scope in the training and validation accuracy, which shows that our model is not overfit even though it's a very small data set. It's a very powerful result because complex models like transformers or BERT have very high tendency when fine-tuned on a very small data set or a very non-diverse data set, have very high tendency to overfit on it. But you can see over here, a Kim-Serial model is performing perfectly fine on training as well as validation accuracy. For example, we've put a couple of tweets over here, and you can see we put the probability obtained from a Kim-Serial model and the classified theme. One can see that it's performing perfectly fine in sense of the probability distributions. As the tweet one is 100% classified as probability one, and second is as it's a very general domain is classified as 0. Yeah. Next.
For headline generation, we are using the pre-trained model called MBART. So MBART is the pre-trained model which has already learned how to denoise the language during the pre-training stage. This way, it has almost captured all the information about any language on which it was pre-trained. We are fine-tuning it on the augmented data set. We are for that dataset, we are simply introducing some kind of noise by replacing some of the tokens randomly with their synonyms, and then giving the model that dataset to make the model. We are not using any kind of translation systems. We are having only MBART model, which is doing both translation and summarization. This model is able to do that because it has already learned how to map two multiple languages into a single space, and it can further decode that to English. So here, even if we have, let's say, Gujarati, Marathi, other languages, this model don't need any translation system. It can simply take all the languages as input and simply decode it to the English language. Next.
Further, we also introduce something called as a routing based layer. So the reason why we have routing based layer is to model some sort of interdependencies between the languages, and also it can be extremely beneficial in the case of low resource languages. For example, you might have Hindi and English to have a large corpus of data available, whereas there might be some kind of local language which is quite similar to Hindi but does not have as much of data as Hindi or English. Therefore, it's necessary to have some sort of way in which the model can learn dependencies between them and accordingly transform all of them. So what we do in this is, at some nth layer, we take the output of all the tokens and then route it into each of these groups colored differently, 1, 2, 3, 4 till G. This routing happens by predicting a probability value for every token. We predict some probability value of what is the probability or chance that it can belong to that particular group. Then we perform some masking operation and route these tokens to each of these groups, perform a transformation on it using a linear layer, and then concatenate all of them together before propagating to the next layer. The reason why we are doing this is that we need the model to identify that these are different languages and also build some sort of dependency between them. Where what would ideally happen is that you would have Hindi tokens being routed to a specific group, you'll have English tokens routed to a different group, and also English tokens based on the word and what it is, it will be routed to the required group and so on. So further, it is also important to ensure that the tokens are routed in a uniform manner across the groups. That is, we do not want all the tokens to go to a single group. Therefore, while training, we introduce something called as a routing loss, which is basically the sum of squares of the fractions of tokens being routed to each of these layers. Also, to increase the randomness or to ensure that the tokens explore all available groups before getting routed to the best one, what we do is we randomly route the token to the second highest probability to ensure that the model kind of captures that information as well.
As you can see in this slide, we are able to get decent score on the validation dataset with mobile tech flag equals to 1. We are able to get 75% headline similarity and the FROG score of around 0.52. In the bottom of the slide, we have shown some examples, and we can clearly see the examples shown are really good in the language structure, and we are able to get very good summarized headline.
Moving on to entity recognition. So I think previously it was brought up that how a sentence like "I love apples" is going to be taken care by your model. So particularly because we are using a rule-based approach, and rule-based approach is always prone to false positives. I've come up with 3 set of rules to make sure that we don't have as many false positives as possible. So first thing is we don't do lemmatization. So lemmatizing a word like apples will convert it to the root word of apple, and that will cause me a problem with my string matching in the branch. Secondly, we have a prior model which predicts the sentence as mobile tech or not, which is the first classifier that we're using, based on which we are going to use a sentence to identify the brands. Even if Apple's food apple is in part of a sentence, is part of classified as mobile tech, I use another named entity recognition model which predicts the entity's category as either organization or product to be filtered through, which will then go into my string matching algorithms to check whether the string is a brand or not, the identified string is a brand or not. With respect to the aspect, after identifying the entities, we use aspect based sentiment analysis model, which is a BERT based model trained on semi-val again, and we use specific task to fine tune the BERT model, which was completely based on laptop and mobile technologies, which we thought was very relevant to the domain. One notable feature that we saw was for articles with large length, the model was largely giving us neutral sentiment throughout. So what we tried to do instead was we converted the articles into its headlines and got the summarization from it, and then predicted the entities and the corresponding sentiment from the headlines of the articles, which not only did save us a few models because we already had the summarization model with us, and also it also made sure that we were able to use the translation things that could be done by MBART itself. Next, please. Yeah, here I've we've put up a example sentence where our model is showing which part of the sentiment is important for predicting the sentiment. So as you can see, the first sentence is Samsung is great, but Apple sucks. So during that sentence, you can see that while predicting for the entity Apple and sucks are the words with highest weights and attention. So this is again, this is a weighted matrix which I create from the self-attention layers obtained from the BERT model, which will give me this. And with this, you can actually observe that pretty clearly it is able to identify both positive, negative, and neutral. And with respect to having multiple entries of the sentiment multiple entries of sentiments for same entity, we go with the maximum rule. Yeah. Next. This is an example of our few predictions. You can see both positive, negative, and neutral exist. And we also got multiple entities with different sentiments. Yeah, thank you. Next.
Yeah, regarding the impact, you can see that it is useful for companies to use this as feedback to improve their products, and also for consumers to understand possible available options. In case of feasibility and scalability, we always ensure that the proposed method can be scaled to multiple languages. Also, the model is fast and provides faster inference speeds without compromising on performance. Also, we have shown that with limited data points, the model is able to capture domain-specific information. This proves that the model can be easily extended for other topics or tasks. Now, we just show a quick app demonstration for the particular task which you have done.
We have built an end-to-end pipeline as the solution to this problem statement. Now we will put one article in this text area. We can clearly see that this article is fairly large and it's having 1 plus as its entity. Now we'll click on update button. Here are the results. We can clearly see that our model is predicting the category nicely, which is mobile tech in this case, and the headline looks decently good. Now this article is more challenging as compared to previous one because it's involving both languages, Hindi and English, and the article is the mixture of both languages. So here the model needs to first understand the Hindi and English structure simultaneously and then decode it back to English. Here's the demonstration of our NER end-to-end pipeline. We will put one tweet here in the text area and we'll click on update button. We can clearly see that our model performs very fastly and it's predicting the correct category, which is mobile tech. Then we can go to the NER results. We can clearly see the two categories which model has predicted, Redmi and Xiaomi, are present in the tweet which we have is also for some other category. We can clearly see that model is able to predict the correct category, which is non-mobile tech, and it's not giving the
Time is up. Please
entities.
stop now.
Yeah.
So now we will move to the Q&A part. Judges, please ask your questions.
Maybe I can go first. Can you all hear me?
Yeah.
Great. So Latin mix, interesting concept. Just want to know what was the impact of this Latin mix on the overall
Yeah.
execution time?
Yes, so we noticed that initially the model was overfitting very heavily on the data set. We were getting around 99% train accuracy, whereas the validation was around 91, 90%. But when we introduced latent mix, the validation increased to 95, while the train kept hovering around 97, 98, and so on. So that means that the model is now focusing on better features instead of just focusing on high level information, just like one word or one character and things like that. So we believe that's the reason why it's very effective.
Sure.
And another thing is, ma'am, that augmenting the data in the latent mix space help to eliminate such use cases which seem mobile tech. If we just look at some words like phones or iPhones are present, but it's not a mobile tech context dependent. So latent mix helped to overcome that.
Sure. But that could have actually impacted your overall time complexity, right? The execution time. Was it?
But this is only for training, right? If I'm not wrong. I just want to mention that this is only for the training purposes, and it's just a linear interpolation. And already the model is very small. It's just 0.9 million parameters, whereas birds are in the ranges of 100 million, 50 million, and so on.
500 million. Yes.
So yes, so all these the execution time is only 0.034 second for a forward pass. So whether we have latent mix or not, it's just that we are doing a linear interpolation with some lambda. So it's not a big compute per se, I would say.
And for the time sake, before latent mixing, the time was 0.0025, and now it's 0.0030. So it's just 5 milliseconds or something of that sort, but it's still very, very less than the BERT.
Sure. So what happens is when you, even if inside the layer create few more linear combinations, your weight optimization time sometimes increase. So I just wanted to know if that's the case here.
Yes. The training time does increase because you need to have more epochs for the model to actually converge. That's definitely true. Although we feel that the trade-off is okay because we see a significant improvement, because what we notice is that the model is just picking up words like smartphone, mobile phone, Samsung. Because if you see the data set which was provided to us, there was a lot of entities which had Samsung in it. So the word Samsung led the model to bias that it was a mobile tech particular thing. So having this sort of thing, we thought that it didn't have that particular problem. Even if we just introduced Samsung for the namesake and didn't necessarily talk about mobile tech, it didn't predict it as a mobile tech. So we think that it's a more important gain than what we are trying to do, because it's a domain specific task.
Thank you so much. I'm good.
Hi. What do you think? What is the one area or multiple areas probably where your entire solution was not working well? What are those areas, and how can you overcome those challenges as well?
We would say that we, at least in our tests, when we did locally our tests, it seemed to perform very well. We didn't notice any difficulty per se. Does anyone want to add on?
For multilingual cases, we were doing exceedingly well. We checked for the first iteration, there were several errors, some statements like what we had shown in the second or third slide, XLMR model solutions. So first we had done that. So the problems coming in it were like, suppose the statement is a humorous sentence but involves an iPhone word, so it was picking the outcome as one. So we tried several iterations, and in the final iteration we got the perfect result. Like we tested on several other the outside cases, but we got accurate results in that. Further on, if we want to add something more, we can do much better in some other tasks. But currently we feel that multilingual test cases for theme classification, summarization, and sentiment classification is working perfectly fine
Okay, thank you.
Okay, team, one question or maybe a bit of a clarification that I'd like to have. So you mentioned about this entire phoneme translation towards the beginning of your presentation.
Yeah.
Okay.
Yes.
So you just want to understand this. So the entire subsequent task that you have done, is it on that phoneme translated data? I mean, is that what is being fed into?
No, it's just for the classification task that we are applying phonemes. For the
Okay.
summarization, we are not applying phonemes. The reason is that for summarization, we needed a better model which can summarize. So when it comes to phonemes, since it's not done anywhere else, we don't have a pre-trained model per se for it to capture that kind of language context like BERT,
Yes.
etc. So we thought that we'll be at a disadvantage if we use that phoneme and phoneme-based architecture. However, there is always a scope of doing it, but given the limited data and the
Yes.
training from scratch thing, we don't think that it'll be particularly useful and it'll put us
See,
at a disadvantage, we thought. That's
if we have a particular scalable data that can have a train like which can act as a training data, like this data was very biased and was not like apt for training the model for such a large model, so we didn't use phoneme. But our intuition was correct as it performed very well on theme classification. So we can use and we should use the phoneme model for research or literature papers for and then develop it into competitions, which we.
Got you. Okay. Thank you. Thanks for answering. I guess that's it. No more questions from our side.
Thank you.
Thank you, sir.
Soumya, we are done. You wanna call out for the team?
Hello? Hello, am I audible? Hello?
Hey, Soumya. Yes, we can hear you.
Yes,
So,
yes.
the next, we will be inviting five judges to the stage, three from the participants, and one participant will be given hand mic. Okay. There is some technical issue.
And
Yes, sir.
Soumya also, before that,
Yes, sir.
hey, Soumya, one more thing. Before next batch comes on board,
Yes.
can you swap me with Pritham as the speaker?
Yes, sir. O- Okay, sir. Okay, so do we need to add someone else as judge or panelist?
No, we are good.
Hello?
We are good,
No,
Soumya.
Soumya, we can start.
So I'm going to call the next team.
Yes. Hi. So just to confirm, is everyone from our side added?
Hello.
Yeah, okay, fine. You can. I can't see others. Soumya, have you added them also?
Uh, 1 minute. Like, what is the problem?
Like, have you added all the
No,
other team
like I'm
members?
adding, I'm in the process. When I will add, I will
Okay.
notify you. Let me add everyone. Then you can start. Nirmal, please accept. Okay.
Hello, is the screen visible?
ठीक है हो गया.
Yes, also it is.
So I have added everyone on the stage. So you can start now.
Fine. Good morning, everyone. We are Team 16 and we present to you our work for Bridgei2i's automated headline and sentiment generator as a part of 9th InterIIT technique. So let's have a quick look upon the objectives of this task. The problem statement can be divided into three subparts. We are given some tweets and articles and we have to classify whether the given tweet/article belongs to mobile technology class or not. If yes, we have to identify the mobile branch in the text and predict the sentiment expressed towards that entity or brand. For the articles belonging to the mobile tech class, we also have to generate their headlines in English language. Before diving into the solution, it is important to know why this task is so important. As we all know, data is the center of attraction of today's world. In fact, it is the major source of income for many billion-dollar companies. The Global Market Insights predicted that the text analytics market will cross a whopping $20 billion mark by 2027. But this data is being generated at an exponential rate. This makes it essential to automate the process of data analytics. Our problem statement can be seen as one of the important tools that mobile companies would use. The identification task can be used to extract the content which is relevant to them. Then the entity sentiment task can let the company know what people are thinking about them or their competitors, what they are doing right, what they are doing wrong, and avoid a potential crisis. The headline generation subtask can be seen as an overview of large chunks of text present. Now proceeding further, I would like to tell you the flow of data in our solution, which will be helpful in understanding what exactly is happening. When a data point is given, we will first apply some data pre-processing techniques and pass it to our model 1, which will identify whether the data points belong to mobile tech or not. If an article pertains to mobile technology, it will be passed to model 3 to generate the headline. The mobile tech data is passed to model 2.1, which detect the entities present in the text and pass it to model 2.2 to provide the sentiment expressed towards that entity.
Thank you, Jay. So now I shall introduce you to the first step of our architecture, basically the data preprocessing. So as explained in the flow diagram, this is the first step, and we divide it into 5 major steps. These are data augmentation. Then we basically drop the duplicates of similar sentences from the training dataset. And then we detect the source language of the article or tweet whatsoever. And then we translate into English language using a Google Translator. Well, as you can see that the first 3 steps are actually involved in the training phase of our architecture, and these 4 and 5 are used during the inference time, and these are the processing done to be in the inference. Then the next part is data augmentation. Well, we carried out a huge amount of data augmentation, both for articles as well as tweets. We used Essence Scrape library to extract 1800 balanced tweets. We used hashtags to distinguish between mobile tech and non-mobile tech tweets. However, we didn't use augmented dataset of tweets since there was a big quality difference between the augmented and given dataset. Thus, we moved to augmentation of articles, and we extracted more than 5,000 articles in both English as well as Hindi from a number of websites. It helped to improve the accuracy of models greatly. Well, this shows some numbers. As you can see that we have around 5,000 augmented articles and around 2,000 articles remained after filtering the dataset, which I shall explain in the next slide. And then in the dev dataset, we also add some augmented articles, which are around 126, and 374 are the articles which remain after filtering. So, well, now after a deep analysis of the dataset, we actually found out that the training dataset contains a large number of similar articles and tweets. And it is important to remove that to avoid the overfitting of a model and build a robust model. Thus, we remove the similar data points using the difflib module. And it basically detects the similar data points and removes them based on root similarity measures or other measures. So after that, the major step of our architecture is language detection. And we detect the source language of articles or tweets using a Python lang detect module. In order to separate English and English, we use BERT vocabulary since lang detect doesn't support English. BERT vocabulary contains English words, thus we may match the tokens of a given sentence with the vocabulary. And if more than 60% tokens match, we declare sentence to be an English sentence. Well, this is useful because we want to translate the articles and we need to know the source language in the Google Translate for translation.
Now let us discuss the task of mobile tech identification. This task is crucial and important as remaining two tasks are dependent on this task. Using an ensemble allows to harness the power of associating faraway words of transformer models and the ability of non-deep learning models to process the entire log input data together. The article classification is done with the help of ensemble of several transformer models, XLMR base, XLMR Hindi plus Electra English, a random forest and an LGBM. You might find it interesting that non-transformer based model have a better performance than the transformer based model. We attribute this to the article being very long. Hence, a large amount of information is lost from them when they are trimmed. This is not required in non-transformer model, leading to better performance. However, it is observed that transformer-based model perform better when tested on newly sampled augmented data, which was from the different distribution as the training and validation data. This showed the domain generalization ability of the transformer model, and it was essential to use them to tackle test cases from previously unseen distributions. Therefore, we take an ensemble of XLMR, Electra, Random Forest, and LGPM. As the tweets are usually smaller, only 140 characters, which are mostly slang or hashtags, not present in any ordinary dictionary. It was observed that non-transformer based models were performing better on them as compared to transformer, although the difference was less. Thus, we made an ensemble of two traditional classifier, random forest and support vector machine, in order to get final result on classifying tweets. Making use of two non-transformer based models pushes the accuracy to 100%, and we use this to perform the final classification on tweets. So we ensemble random forest plus SVM due to better performance on the augmented as well as dev set.
Entity sentiment analysis. So for this subtask, we first identify the mobile brand using the knowledge of the mobile companies present in the real world. Then we detect sentiment of these companies using the transformer models. Since the company being a mobile brand is a fact that one should know, instead of targeting this task with techniques such as NER, we created a list of 60 plus mobile companies and then deploy string matching techniques to detect if that brand is present in text or not. As the tweets and article might have some spelling errors, we use difflib module to ensure that these errors are taken care of. For detecting the branch written in Hindi, we again pre-obtain the branch and map it to English with the help of a predefined dictionary. Also note that if n number of entities are detected in the article, the input to the sentiment detection model will be n data points with same text and different entities. Now, our task becomes to predict the sentiment given the text and the target entity. As we are not provided with any entity-based sentiment analysis dataset, We rely on domain adaptation to first train transformers on the sentiment analysis or the similar field of data set and then fine tune them over a manually annotated small manually annotated data set. We experimented majorly with two models in this approach. First, ERNIE. ERNIE is a popular transformer model benchmarking new SOTAs on many sentiment analysis tasks. We first trained ERNIE on a big corpus of big tech and then on Apple review dataset. Now we fine tune on a small manually annotated dataset of around 300 pieces and 200 articles. To classify the sentiment, we use the linear layer over the top of the ERNIE. To make the prediction of sentiment dependent on the entity, instead of taking the embeddings of CLS token for classification, we use the average of embeddings of the entities. To increase the accuracy further, we use the signal in the form of double quote. What we basically did is we encode the target entity in double quotes. This is supposed to produce better contextual representation of text by telling the model to focus more on that word. But since the deep learning model is kind of a black box, this is a hypothesis developed after seeing the results. For training the second model differently, so that we can ensemble on both of the models having the different strength, we trained the XLMR model on the Amazon cell phone review and electronics review dataset. Then we fine-tuned it on manually annotated datasets. We used a different approach to fine-tune the model. To predict the output, we appended the target entity at the end of the sentence with a separated token and then used its embedding to predict the sentiment. We use the double quote signal scheme here also. Next slide. So in this slide, you can basically see the visualization of what we are doing in this task. So what we first, it is for the particular ERNIE model. First, the entities are detected from the sentence, which will come out to be Samsung and Apple in the case in the sentence written on the slide. If not written already in English, we translate the input sentence to English. ERNIE can be only used for English input. Since two entities are detected, Samsung and Apple, two data points are to be classified by our model. The target entity is Samsung in first case and Apple in the second case are enclosed with the quotes and passed through ERNIE tokenizer in model. The transformer will output the token embeddings of the sentence. Now for the first case, we take average of embeddings of all the Samsung tokens and pass it to the classifier to predict the sentiment as positive in first and negative in the second case. In the next slide, you can see the accuracy on the dev set. The key takeaways are that the ensemble and XLMR do not differ much in accuracy and not much variation was absorbed across, to our surprise actually, across the languages.
Now let us discuss the headline generation task. Formally, we can define the headline generation task as supervised machine learning model, which maps multilingual articles, which in this case is Hindi, English, to the English headline of maximum 20 words. We believe that transformer-based models are strictly more powerful than the other deep learning models such as LSTM and pointer generation. Therefore, we are focused on the pre-trained monolingual as well as multilingual transformer-based models such as BART, MBART, T5, MT5, M2, M100 and Pegasus. Also, we preferred and used models pre-trained on CNN or XM dataset, which consist of news articles and hence overlap with this task. After initial exploration, we decided to use following three approaches in order to address the multilinguality in the article. Approach 1, original to translation to headline. This model uses explicit translation. Approach 2, original to headline to translation. This model also uses explicit translation but only on headline, 20 words. Approach 3, original to headline. We train a multilingual text-to-text generation model which maps the multilingual original article to English headline, eliminating the need for translation model at all. This model uses implicit translation. In terms of scalability, we believe that approach 1 is most scalable. So suppose we want to scale this headline model to new language Gujarati. Then in approach 1, we only need to add the translation compatibility, no need to fine tune, and we are done. In approach 2, we need to fine tune the multilingual model briefly so that it generates appropriate Gujarati headline and add translation compatibility. In approach 3, we need to train the model for longer period of time as translation is implicit. The number in the parenthesis denotes the approach number, and these are the subset of experiments which perform best in the segments. As we can see that the approach 1 BART large performed best among all the models, and with augmented dataset described in earlier slides, we were able to boost the score even further. Surprisingly, the approach 3 worked better than the approach 1, and due to the implicit translation. And we also experimented with the ensembling of two BART large model, fine-tuned on two different data sets, one being the original and other being the augmented. The result of ensembles were best among all the model, but with large GPU RAMs runtime and the inference time being almost double. We ensemble using the bean score, and although the bean score were not available in standard trainer, therefore it was a new experience for us to extract bean scores from inside the model and correctly ensemble them to boost the performance. This is an interesting comparison between the three models, which increased our confidence in approach 1 even further. So as we can see, the article is in Hindi language to understand the multilingual effect. Approach 1 predict best suited headline. In approach 2, the sentence is syntactically incorrect, and in approach 3, it is factually incorrect.
Thanks, Nirmal. So let us discuss some final remarks and conclusions. Well, on this slide, it shows some numbers, basically the results of our on the test dataset, right? Now let us discuss the scalability of our model. Well, our implementation mainly uses translated articles and tweets, and we mainly use Google Translate, which supports more than 150 languages. So, and since we have to add the translation in the beginning phase and the initial phase of our data, thus it makes it highly scalable because Google Translate offers many languages. Then scalability for data is also an important issue, and there comes the inference speed of a task. So for reducing the inference speed, we use the FP16 acceleration on GPU servers to reduce the time complexity of each and every training model.
Time is up.
And
Please
moreover,
wrap in 30 seconds.
on top of that, we also translated only the English articles and not all of the articles. Well, now comes the impact and the applications of our model. So here is this. Well, you can see that we have used different models for different subtasks, which makes the our approach quite impressive. And moreover, these approaches can be extended to other domains as well, like politics, fashion, etc. Because we haven't done anything specific to mobile tech, and in spite of the
Stop.
entity
Time.
detection.
You have to stop.
Thank you. We are open for questions.
So the Q&A round will begin. Judges, please ask your questions.
Okay. So for entity detection, which is a brand identification, you have used, I mean, you are using some similarity technique to find, you are matching the words with a set of dictionary words and then finding the brand. Am I correct?
Yes, sir. Yes.
Okay. Do you think this is scalable, given that you are matching every word present in an article with a word present in a dictionary?
Well,
How
yeah,
do you think
you're
that?
right. Like, let's say we have any word and Samsung, let's say we have a word Samsung, and in it, we are not actually matching each and actually word character by character. Like, let's say it drops some characters from it, and then we are using the difflib module, which actually calculates uh, the word similarity between the two. I mean, in morphological level, in a word level, basically. So that ways we can detect some spelling errors or something like that. However, in terms of the scalability issue, like whether it is scalable for other languages or not, well, you see, for other languages, anyways, you have to train an NER model, and for in a commercial world, basically we are a fast forward moving world. So basically, you have to train the model for new languages and then get prepared all of the data set, then manually tag them. It will take a lot of time. So I think rule based entity classification for that will be easily available because you can translate each of the given, say, let's say Samsung in Japanese, let's say you can translate it into English and then basically use it or then detect it. So that's what I think.
Okay. I hope you're aware that, I mean, even a change in one single letter in the company name can result in a totally different brand name.
Yeah,
So,
you are right. You are right. But actually, it doesn't not. I mean, all right. Well, yeah,
only
you.
difference between an iPhone and a phone is the one letter I. So,
Um, Well, yeah, you're right, actually right. I think Parth can explain better on
So
this.
that is the yes, sir. So that is the reason why we actually use difflib. So when we actually use difflib and we get a similarity score, so sir, that similarity score is actually based on the longest contiguous sequence of the matching words, matching tokens. So when that similarity score actually crosses a particular threshold, then we get that. Then we it's a kind of extract that word. So in that way, actually we actually prevent extreme rule based string matching, but we introduce some sort of flexibility in our algorithm in that manner.
Okay. I mean, it still holds true. The iPhone will still get matched to a phone, a string called phone.
Yeah. Yes, sir, you're right.
Okay, I'm good.
Okay, if I may ask the next question. Am I audible?
Yes, ma'am. Yes.
Great. Can you go to the approach 1, approach 2, approach 3 slide, please? And while you're doing that, I'll ask my question. See, you've used multiple models and you've used internal evaluation metric for ensembling. My question to you is for approach 1, approach 2, approach 3, if you have to build a pipeline which is automatically able to identify which approach will work the best, how does the pipeline or how will the pipeline work? So how does that pipeline looks like?
Yes, so as we have discussed the ensembling possibility in approach 1, we can extend the similar possibility in ensembling the various approaches too. So we can actually get the birds beam score from each of the approaches final models, and we can add a MLP layer on top of it, and we can train briefly for around briefly fine tune briefly so that it learns the correlation of beam
Yeah. So
scores.
Nirmal, let me just clarify. I'm not talking about within approach 1. I'm talking about across. How do you
Yes,
know?
yes, yes.
How do you know somebody or something has to pick approach 1 versus 2 or versus 3?
Well, in our approach, basically, we are only using the approach one. I mean, we are not using all of the approaches and detecting that which of them will work best. Based on our experiments, we concluded that approach one is as of far working the best, and that's why we are only sticking to it. What you are saying is like using all of the three approaches and detecting that which of them will work the best in for a given particular example.
Yes.
But we haven't done that thing actually. We have stick to approach one only based on the results.
Okay.
So
So as
actually,
we go,
for the
sorry, go
last
ahead.
question, I would like to add that actually phone isn't in our list of brands because iPhone isn't actually a brand. The brand is Apple. So that iPhone and the phone matching wouldn't exactly work. So yeah, I wanted to just add to that last answer which we gave.
Yeah, sure.
So maybe I'll ask the third and last question. There were a lot of information that you augmented at the beginning for your training purpose, and some of it is also used for understanding the impact and the accuracy of the models. Now, two questions. One is why did what made you believe about augmenting the data? And second is technically, do you think will it is there a chance of that adding any biases in terms of the data that we have given to you, and if at all, how are you controlling for it?
Yes, sir. I would actually like to take that question. So, for the first question, it is actually a general practice that whenever we handle a data science problem or a data science project, it is a general concept that data augmentation is believed to supposedly increase the accuracy of the model. So, with our general approach, we first went ahead to data augmentation. Now, for the second part of the problem, sir, what you said is truly correct because it is right that if the data set is biased in certain manner, if the quality doesn't match of our quality of the data set, then it it can result in bad results. And this is actually what happened for the tweets. For the augmented data sets of the tweet, we found out that the quality of our augmented data set was different from that of the data set which was given to us. And this we found out when we tested our pre-trained models on the data set given to us and then evaluated them on that augmented data set versus the difference when we got it on by training and evaluating on the augmented data set. There was a vast difference in the results. So this gave us that the augmented data set of the tweet couldn't be exactly used with the data sets given to us. For the articles, when we use the augmented data set of the articles actually allowed us to get to the fact that we used like the non-traditional models like the LGBM and the gradient boosting models were actually overfitting when we are using the character-based the character level TF-IDF embeddings. So this actually allowed us to predict that overfitting, because when we tested them on the augmented dataset versus when we tested the transformer models on the augmented dataset, the transformer models didn't actually have a dip in their accuracy, while the traditional models did. So yeah, so with this we came to know that the augmented dataset of the articles was actually helping us, and for tweets it was not.
Okay, thank you. I think that's it from our side. Thank you for your presentation.
Thank you, everyone. So
Thank you.
we will be taking a short break of 20 minutes. Judges, you don't need to leave the stage. We will be resuming in 20 minutes because there is some technical issue which need to be resolved. So wait for
Soumya? Hello?
Yes, sir. Tell me. I am Ayush from his colleague.
Yeah, Ayush, we need speaker access for Soumya.
Yeah.
Yeah, I'll,
Okay, I'm inviting him to stage. 1 second.
I think I got the speaker access. Am I audible to everyone?
Yes, sir. You are audible.
Yes.
Anuj, please add Jaskaran also.
He's already on stage, I guess.
Yeah, I think I.
Great paper is here.
I'm here. I'm here, Glenn.
Soumya, we are good.
Hello. So, sir, is everything all right? Like the panels and the judges?
Yes, we are good. Let's start.
Yes, sir. Okay. Yes. So 1 minute. Like there is some issue. So 1 minute only.
Jasper, it's 15 minutes per presentation, then 5 minutes Q&A.
Yes, sir.
Hello, Mr. Glenn Lobo, sir. Please mail your ID, like DM me your ID.
Okay.
Team 4, be ready. Like, please raise your hand.
Hello, am I audible?
Yes. So
Okay,
all the
yeah.
participants are here. You can start.
Okay, no, just a minute, Soumya. So one thing, we have five speakers. We are using all five speakers. So that's. Can you please briefly explain how the mic passing on thing would work so that everything proceeds
So
smoothly?
like,
So that we,
current scenario is like four participants will be invited as speaker on the stage, and the fifth participant will be
okay,
given a hand mic.
okay. So can you please give the hand mic to Shivam Singh? I think he might be raising his hand.
Currently I don't. Yeah.
From,
Okay. I have passed him the hand mic.
okay, thank you so much.
So we
So
shall be starting. Okay.
okay,
Thank you.
okay. Shall we start, Soumya? Have you started
Yeah.
the time?
Yeah.
Okay, thank you. Okay, so good morning, everyone, respected panel judges and our fellow competitors. I am Kshitij, and along with my team, we'll present our approach to Bridgei2i's automatic sentiment and headline generator. And the organizing team calls us H2B2Y4, so for any grading purposes, if that's needed. So if we start with the introduction, so here are some of the points we would like to stress upon in our presentation, and these are some of the salient features of our approach. So one, we have used simpler and faster models for binary classification. Two, we have translated all of the data to English for greater scalability and accuracy, as we'll see in a bit. We have used regex matching for brand identification because of the speed gain and due to the small size of the matching set. And four, we have used advanced models like T5 for headline generation. Okay, next up. So this is a whole full end-to-end workflow. This is the whole diagram. So I'll just leave it on the screen for a bit. So as you can see, a lot is going on here. So we'll actually break up every part and try to explain everything as clearly as we can. And as per the rules, we'll take questions at the end. Okay, moving on. Yeah, so starting with the pre-processing and cleaning. So we mentioned the steps we have taken for the tweets. So most of them are pretty usual steps that anyone would take. The fourth step is particularly important, where we use the open source library Demoji to replace the emojis with their text descriptors. And here we have an example from the real data, from the training data, where you can see that how that is useful, because without the emoji description, it is kind of ambiguous, the sentiment, but with that added, it actually helps. So we have used that. Next up, we look for articles. Yeah, so again, we have mentioned the steps we've used for articles. Mostly the usual steps. One thing is like we removed the usage of the dot symbol. So we use it for decimal numbers and use it for full stops, right? So one thing that we noticed while exploring the data was that in many of the articles where the dot was used for decimal numbers, maybe due to some scraping issue or issues of the kind, or some formatting issue, there were some spaces. So as you can see in this example from the training data, we have MIUI 12 space point space 5 and even 6 point space 81 inch AMOLED. So these kind of issues actually caused a lot of trouble when you were doing sentence segmentation in the further approaches, where we actually segment the article into sentences to process. So that's why this was when we wrote a simple regex expression which actually condenses all these occurrences, and actually that unexpectedly offered a huge boost in sentence segmentation and all those. We got much more coherent, and like the sentence segments actually made a lot of sense, and they were not very small. Okay, moving on. Shivam, do you have the hand off mic? Would you like to take over?
Sure. For binary classification, we decided to go forward with a TF-IDF XGBoost classifier. In the first part, the TF-IDF vectorizer takes in the document, in this case articles or tweets, and then calculates the frequency of a particular term in the document. And then the inverse document frequency function divides the specific term frequency by the sum of the frequency of the term in the complete set of document. This ensured us that the term which was present in a document significantly more as compared to the complete collection got a higher weight, and the XGBoost classifier was used to more accurately predict the article or tweet due to the boosting iterations. Moving on to the advantages of the model. This model in itself is rather simple and hence can be easily customized without a lot of effort. And if there are some changes in the data or constraints, it would not require a complete team to fine tune it, and it can be done rather easily. Apart from that, the model is much smaller, and it trains as well as produces inferences much faster than a larger model like BERT. But as you can see from the slide, use about 40 times the time required to train and produce inferences. This can be a significant issue in cases where requests for classification have to be processed instantly. And also BERT also took a lot more space as compared to our model, which would be approximately 60 times, and which can be a hindrance to scalability if more requests have to be made and multiple instances of the model have to be deployed, and therefore it has significant cost advantages as well. And all these advantages were created by not sacrificing the accuracy to a significant degree, and as you can see from the leaderboard itself.
Yeah, so as you mentioned, so we have focused on using simple models which provide good performance and good speed, and with very minimal drop in performance, as you can see with the performance on the leaderboard. So now we move up to language detection. So first of all, why do we even need to do language detection? Because in our pipeline, as we mentioned, we translate everything to English ultimately. So basically, this is important to basically separate the text which is not English. And even if you want to process each language text separately or with a different pipeline, this can be done. So that's why we worked on this. And this actually was an interesting problem because out of the box, many libraries were not giving very good performance. So we actually combined several open source libraries with our own custom rule-based logic. So we used LangDetect for English text identification. We found that it was very accurate in that, and it was doing good in that. We used this Indic transliteration repo of GitHub to detect Devanagari characters in Hindi, and it also has character sets for Marathi and many other regional languages. And we just basically kept that the texts which had a low probability in both Hindi and English, we just took them as English. Now this might seem like quite a rudimentary approach, but we actually found that this worked well in practice and was able to separate the text based on language pretty accurately. Next up, we have language translation. Yeah, so why did we decide to translate? So early on when we were working on the data, so we found that tasks like headline generation were giving poor results on multilingual data. So therefore we started exploring the avenues where we can actually translate everything to English. And actually it did not only boost up the accuracy, it even helped the model scalability. And if you want to understand why, just think of what would you have to do if you needed to add a new language. So when we say scalability, right now we're talking about language scalability to add different languages. So if we need to add a new language and we have, say, different models for different languages, or we use a multilingual model, so on Indian regional languages, we might not get very good performance even with multilingual models. And if you're using different models, then it will take a whole lot of time to gather the data and train on separate models. But APIs like Google and Microsoft have already do a very good job of translating things to English for many of the Indian languages as well. And surprisingly, Google API can even translate English text to English. It first transliterates and then translates. So this was a very handy thing that we used to translate everything into English. Now, in the spirit of the competition, we had to only use open source and free tools. So we ended up using an open source Google Translate API. It is an unofficial API and it kind of emulates the web API calls we do in the browser. So as a courtesy, we had to add a time.sleep interval so that we don't get flagged or we don't flood the server, right? So that kind of ended up being a bottleneck in our pipeline because of that time.sleep. But all in all, it provided huge additional benefits. And if we deploy it in a service, one can easily get a subscription for translation API service for modest fee. So they are modestly priced. So that's why we decided to go for this. Next up.
Now coming to the problem of sentiment brand identification followed by sentiment classification related to that brand. Now one of the major hurdles that we faced in this task was that regarding the length of the articles. The articles had an average word count of around 500 words. So we had to come up with an efficient way to segment the articles into brand specific contexts. Proceed to the next slide. Yeah. Now, in order to segment the articles, we actually, after having tried quite a lot of experiments, we resorted to a rule-based method in which we define the context of an article by the substring which starts with the occurrence of that brand, and it continues till the next occurrence of some other brand. Now, as you can see, there's an example in which our rule-based method indeed gave decent segmentation results. Now, moving on to the next slide. Now, the next task was to identify or which brand are we exactly talking about in an article or a tweet. Now, actually, it is pretty intuitive to use a named entity recognizer to address this problem. But having thought for a while, it appeared to us that this problem was rather easier. So it would be like using a sledgehammer to crack a nut if we were to go with a machine learning model for this simpler tasks. So we resorted to a regular expression matching approach in which we made a dictionary of all the mobile brands which are present in the mobile tech space, and we use some handcrafted regular expressions. As you can see, there is an example on the slide in which a pattern we have created so that it definitely separates Oppo from a similar word opportunity, which also has the same prefix. So in this way, we got pretty decent results in all these pre-processing parts. Moving on to the next slide.
Okay, so for the task of sentiment classification, we went ahead with using context embeddings. So the pipeline was a pretty generic one where we used the embeddings from a language model like BERT, and then we used a linear classifier on top of it to get the class logits. So the main question here was which embeddings to use. So our team went ahead with mainly two approaches. The first one was using tokens specific to only brand occurrences present in the text. So how we handled multiple occurrences was that we selected the embeddings for the brand occurrences, and then we averaged them to get a final embedding. So a visual representation of an example would be something like the Nokia was present as at space 2 and at index 9. So we just took the embeddings from both and then averaged it, and then we use a linear classifier on top of it, and it worked pretty well. But in the validation set, we found that there were very few examples present such that they had multiple brand occurrences and conflicting sentiments attached to it. And also we noticed that the number of such occurrences were so low, like 4 or 5 examples only. So there wasn't enough data to train a token classifier. So we went ahead with a simpler model where the final embedding was calculated by simply calculating the max pooled version of the final layer output. So what we extra did was only unfreeze the final layer of the bird. So what it helped to do was that uh, it allowed us to gather the attention weights for context representation. So next up was fine tuning and validating our approach. So we hand labeled around 200 tweets for model selection and evaluation. Further, we also tried to explore some external data set for this particular task. We used the Amazon mobile review dataset, but it didn't perform very well on our validation set. The main particular reason was the text was not Indian context specific. So we searched the internet for some bird checkpoints trained especially on English and Indian domain text, and these gave satisfactory results. So we went ahead with it. Next up.
So the first question that I would be addressing is why employ abstractive headline generation. So there are two major ways for summary and headline generation. Extractive models extract phrases from the articles to generate summaries and headlines, whereas abstractive models generate summaries and headlines from scratch. So regarding this question, the reasons for this are quite evident from our examples. As one can clearly see in the example on the right, PlayStation 5 reviews, Sony's PS5 is an upgrade worth your money. These headlines generated is quite catchy, unlike headlines generated by abstractive methods, which are usually pale. And on the left, one can see an example where the extractive headline is significantly longer and less informative than the abstractive headline. So moving on, next. So here we, Aditya, change the slide. So moving on, next we observe that an abstractive model may also perform extractive headline generation in cases where the article essence is only by a few phrases in it. So on the left, you can see an example where in the first example, the model copies the sentence, the model basically extracts the sentence from a middle of the paragraph, and in the second one, it basically just takes off the first line from the paragraph. So this basically shows that an abstractive model can do extractive summarization as well. Moving on. So coming to our approach, since we use only English data, we need not worry about the language, and our approach is extremely scalable. Since we use T5 for experiments, since T5 models work well in both language generation and understanding tasks, we use it for experiment. And its adaptability and domain that it covers is extremely high, since it's used for both natural language generation as well as natural language understanding tasks. So moving on. We compare our experiments, our model with a few other pre-trained models as well. One of them being Pegasus, which is basically a model that is specifically pre-trained for abstractive summarization, and MT5, which is a multilingual version of T5, where we do not use the translated data. So in spite of being nearly 3 times bigger in size than T5, Pegasus doesn't outperform it. And since the data given to us
Time
was
is up.
extremely
Please wrap
noisy,
in 30 seconds.
Non-English part, we actually do not go for it. Next slide. T5 offers the best performance and memory trade-off, since you can see on the slide the inference and training time, and has significantly lower memory requirements than Pegasus. So our headline model generation is apt. We could always go for bigger versions of T5. We use the base one, but again, scalability becomes an issue for mobile devices. So that's all from our side. Thank you. We would love to hear any advices.
Okay. So now the Q&A part will begin. Judges, please ask your questions.
Jasper, you want to go ahead, or can I ask?
Okay, I'll go first. So for article classification and a tweet classification as well, you have used a TF-IDF XGB classifier. What do you think is the limitation of that model?
Sir, one of the limitations is like we did see examples of articles where there were mentions of brands like Google, but not in context of mobile technology, right? So those kinds of examples of those kinds were kind of being misclassified. So we had to kind of change our data a bit, like add more features and try to engineer that out of the model. So I think that was a challenge. But the performance drop that we saw from deep models like BERT were not as much. So we got thought to go for it. So one more thing was that, sir, the data for sentiment analysis and headline generation actually drops to 1/4 after the binary classification. So the ratio of mobile theme to non-mobile theme is about 1:4. So if we gain speed in the if we gain speed in the binary classification, we don't actually need to pass that 3/4 of data through the deep models for sentiment and headline. So we thought that as the data is also 4 times bigger, so that might be a good thing to go with faster and more scalable models rather than BERT. Does that make sense? Does that answer your question, sir?
Also, I would like to add another issue here, that these these embeddings don't use context. So these are, but they still manage to do the work because of the inverse document frequency.
Okay. And when you are trying to identify a language of a given document, you were able to identify Hindi and English. And whenever you had a probability lower for Hindi and English, you classified that as a English document. Is that understanding correct?
Yeah, sir. So our rule-based approaches worked like that. So we had confident classifiers for Hindi and English. So basically, a presence of some number of Devanagari characters pointed to Hindi because our models were all English. So we would have to translate those characters anyway. So we just flagged any occurrence of a Hindi Devanagari character for Hindi and for English, and those that were left out. So low probability of English and no Devanagari characters, those were classified as English in for this competition.
So what if I add one more language into your data? Then how will the classification work then? I mean, because for the new category also, your probability for Hindi and English would be also low, right?
Yeah. So, sir, the package that we use, the repo, it's called InterIIT transliteration. So it has a support for other languages as well. So it supports Marathi, Kannada, and all those languages. So we thought that we can actually use and like include its usage more for detecting such languages. But for this competition, it actually worked good for English, Hindi, and English. That actually worked good. But there is also always a scope for expanding.
Yeah, sir, we could also scale it by the number of languages we are using, right? The probabilities, like normalize it with respect to the number of languages. So English will still be significantly lower.
Okay. Got it. Thank you.
Okay. One question from my side. So in this problem statement, you are kind of identifying, let's say, mobile brands, right? So do you think, let's say, the approach that you have kind of used to, do this identification, tomorrow if I kind of change the use case from identifying, let's say, mobile brands to some other form of brands, like let's say some other products where the number of brands possible across all product ranges is very high, will your approach be scalable, or do you think it will not be? And if so, why?
Okay, sir, I would like to take that. So for mobile brands, what we did was we basically scraped some of the mobile websites and just found out all the companies. So a lot of these brand identification problems, the brand names are available publicly. So we don't think that we would get a surprisingly unknown brand. And if it does, it will be very rare. So for such cases where the brand names are available online on some site, so we can just scrape it and add it to a set. But you are right. If we have some new brands or we are in unknown territory where we don't know what brands actually do this, so this might not be work well in that case. It does. Is that okay, sir? Yeah.
I understand. So any thought, like, let's say I'm talking about, let's say, food brands, or some let's say, daily consumer product brands. In those cases, what kind of brand identification ideally you should have thought about, or you can think about?
So then we could have gone for like rule based, which use the grammar of the sentence. So we did try that too. So which basically try to extract the entities using just the rules. But the thing was that the data was pretty noisy when you translate stuff, and you get all that noise, so that actually throws the model off. So that's why we just went for simple regex matching, and we saw that the performance was pretty good with simple regex. So that's why we did go for that. And we can, as I said, we can always scrape other brand lists and add it. But you are right. In such cases, we might have to look for other approaches.
Okay, I'm good from my side.
Okay, Somrit, so I would like to add one point to your question, that this approach is rather highly customizable. For example, when we looked at our evaluation data, the data that you guys evaluated us on, so we found that there was some brands in our dictionary that you guys were not considering as mobile tech. So there was this scope for us that if we have identified that these brands are not in our interest, so we can instantly drop that, and it would be very hard for doing the same thing with a BERT model or a NER model. We have to retrain the whole thing. So yeah, this is a very customizable approach too.
Maybe I'll go for the third and probably the last question. So from from overall scalability standpoint, looking at your end-to-end pipeline, starting from the data, so-called data cleaning, data augmentation, to actually the headline generation. What part of this overall exercise you felt will take or is taking maximum amount of time, or maybe maximum amount of resources? And given time, what might be some innovative ways you might want to drive some sort of reduction on those resources?
Okay, sir. I would like to take that first, if no one else is answering from my team. So, okay. So one thing in hindsight, so there are a lot of things that we learned in hindsight from this competition, and one thing was that we underestimated that we did not have enough data. So for training any kind of models, that we actually obviously require data, right? So we, in hindsight, we would have spent much more time actually hand labeling the data, because those kind of approaches provide the more performance boost as compared to selecting models. Because if you have good quality data which you have hand labeled with a certain subset of your team, and actually it does not take much time. So I think if we took us half an hour, possibly for 100, half an hour or 40 minutes for 100 examples for tweets, right? And it was pretty easy, because in tweets you just look at the tweet and you can get the sentiment. So that kind of things actually we would have stressed more time on, which we kind of started late in the whole competition time. So that is one thing which took a good amount of time investment from our side, when we should have started that earlier. Apart from that, I think model selection and all that approaches did take some time, but the pre-processing and so choosing the rules for language detection, right? So for things like that, we did not have an out-of-the-box package to use directly on GitHub or something like that. So we had to actually combine multiple open source libraries and then see how it was doing. So those things actually also
I'm
took.
sorry to stop you. My question was more about the runtime, the training time, right? So have multiple
Yes,
different
sir.
parts of the
Okay.
solution.
Oh,
Sir, I
sorry,
would
sorry.
like to.
Sorry, I misunderstood. Yeah, Pranav, please take that.
Yeah, so sir, most of our approaches are binary classification to detect mobile theme is based on XGBoost classifier, and most of our pre-processing as well as language identification, everything's basically based on rule regex matching and basic language rules. So all those are very fast. The only place where we have found that the model takes a bit of extra time is the translation part. And our headline generation is also really fast, because we are using a base version of T5, which makes it again really fast. We are able to instantaneously generate headlines for 64 articles in 2 minutes. And that's not on a moderately sized GPU. So if we have bigger ones, we could do it even faster. So since translation, we are using the unofficial API, the free version, or you may say. So that is the sort of bottleneck that we have in our approach. Rest is, since most of it is rule based, it's really quick.
Okay, thank you. I think that's
Okay,
what we
thank you,
had
sir.
from our side as Q&A.
Okay, thank you.
Thank you, everyone. So, judges, can we proceed to the next presentation?
Give us 2 minutes.
Okay.
If that is
Hey, hello. Am I audible?
Yes, Kit.
Sir, are we good to go?
Yes, Soumya.
Okay. So the participant of team number 22, please raise your hand.
Soumya, could you add Kirti and Akash from our end?
Hello? Can you, Mr. Akash Rawat, sir, please rejoin? Like, there is some issue here. Kriti Ranjan, sir, please rejoin. Yes.
Soumya, shall we start?
So, okay, from your team, only 3 participants are on stage. So,
Yes.
okay, we can start. You can start. Hello, am I audible?
We can hear you.
Yes, you're audible.
Yes.
We are having some internet issue right now. We are trying to cope up with that.
Okay.
Is my screen visible? The presentation, is it visible?
Yes.
Yes.
Yes, Anshu. All right. Okay. Yeah. Sorry. So, sorry for keeping you waiting, guys. First of all, a warm welcome to everyone present here. I'm Anshul, and I'm with another one of my teammates, Tanmay, and we'll also have a team leader, Abhishek. He's facing some internet issue. Hopefully, it will subside. So coming to the problem statement over here. So the first problem statement, the problem statement was basically to sort of develop an intelligent system that could first identify the theme of the tweets and articles, if it is pertaining to mobile technology or not, and then it should identify the particular brand present in that piece of text, rather it be a tweet or article, and then it should identify the sentiments against that brand in that particular tweet or paragraph, say it is negative or positive. And again, and the task also involved generating a one sentence headline uh, for the articles that are on that particular theme for the positive class. That so so the next step is just is a data flow diagram. It's just trying to summarize what we're trying to do over here. So the initial data set that was given to us, the first task. Hello.
Anshul, can you keep the slides in presenter mode?
All right, sure. I'm just trying to wait. Hold on. Yes. All right, here it is. So okay, so the next step was to.
Anshul, can you keep the slides in presenter mode? All right, sure.
Are you not able to? Yeah, it's presenting, right?
Yeah, it's visible.
All right, sure. Sorry for that. Okay, so the first step again was to pre-process the text, because so you see the data, when we observed the data set, it was heavily skewed, and while like during our initial we were getting a high training accuracy, like it was overfitting, and we observed that it was overfitting. We needed to sort of pre-process the text. So the first thing we did was removing the duplicate tweets, the duplicate rows, and then we converted all the text into lowercase, removed the punctuation, and then tokenize the text basically, and the next step was removing certain redundant stop words from the NLTK stop word library, words like the and articles and whatnot, and then lemmatizing the words further, basically getting the words which we actually need to sort of make our model, and then vectorize them, grouping them together. The next step was and then the team was divided into. The next step was classifying the theme. If the theme was mobile tech, we stopped our classification there and there itself, because no other. I'm sorry. If the theme was not mobile, not pertaining to mobile tech, then we had to stop the classification. And if it did pertain to it, then we had to go towards. We went forward with extracting the brand name that was present in that particular theme, and we did find a brand in it, we ran it through a sentiment and analyzer. And so the thing was, we sort of separated the two tasks, extracting the brand and analyzing the sentiment, and then we gave the output, whether the sentiment towards the brand was in positive light or in negative. The other step was creating a headline, and we just basically ran it through our headline generator, as you'll see in the further slides as we go through it. So over here. Okay, so the first step about the theme, the first step, as you said, as you noted, was regarding the classification of the theme. So the best split ratio that we could find was 70-30, which was giving us an optimal accuracy. And then we vectorized it using the term frequency and inverse document frequency approach. So what it actually does is that the term frequency, it summarizes how often a particular name appears within a document, and the inverse, the TFI vectorization, the term frequency, like inverse document frequency, it scales down the word whose frequency which appear a lot more often across the documents. So what it does is it gives more emphasis to certain words which appear rarely across the document, which might perhaps give us a better contextualization of the material present inside the particular article or text. And so then we had we also tried other vectorization techniques like count vectorizer, like word2vec, one hot encoding and whatnot. But this is the method which gave us the best results. And then for classifying, it was a binary classification task. Of course, we used SVM because we found it to be effective with high dimensional data, and but it also didn't need much training data to get accurate results. Okay. Now for token, for brand extraction, we after using NLTK library to tokenize the clean text, we had a list of the names of brands. Like one was manually extracting them, and and we also use another method of using Spacey, and we sort of match brand names to a particular we implemented a lookup table to sort of identify a particular brand. So now the main issue with this thing is that despite having a lookup table for identifying brands, having a list of them, in test cases, there's a chance that we might have brands which might not be in this particular lookup list, and which would obviously make the task difficult. So we also use the part of space. We also we use this particular tag in Spacey, using the part of speech tagging, which named org, which specifies companies and organization given the contextual data. So moving forward, okay. So the next step was going through the sentiment analysis. So the process data was run through Flare. So Flare library is we found it to be very efficient with respect to using multiple models, and so it sort of gave us the polarity and subjectivity of the tweets. But one of the sort of bottlenecks was we needed to do it for Hindi text as well. So for like Hindi and English, we ran it through the Google Translate API, and we basically translated it to English and then used the Flare model on it. And so now the was like have a sort of identifying the brand specific sentiment. There could be instances of multiple brands being present in a particular tweet. So what we did was we filtered out the objectives that were present closer to the particular brand, because what we observed from most of the data set was that an adjective which was associated with a particular brand would appear closer to it in the sentence or a paragraph. And then so and then we performed the sentiment analysis on the filtered adjectives, and we could obviously vectorize and we could mark them as positive or negative for the filtered out brands. About the headline generation, so the first step was cleaning the text, removing the punctuation, the emojis, and tokenization and lemmatization to sort of get the sort of text which would be relevant for us, and removing the stop words, vectorization. This is similar to the pre-processing for the previous step as well. Now the next step was using the Google Translator to translate these texts into like from different languages, since we had Hindi and English in the particular data set as well, to English. Again, the Google Translator API, and then we sort of implemented transfer learning using the Google's T5 for text summarization. So what it does is it pairs. So given an input, it gives us an output as well. So that was one of the features of using Google's T5, which really helped us in translating. Then the next step was, since the headlines were to be limited, like the headlines needed to be shorter than a particular length. So we trimmed it to contain a max of 100 tokens or words in the particular headline. And so for longer articles, we extensively removed certain words which were which are not occurring that frequently and which were sort of redundant. And for the trimmed articles, there was we didn't not the removal of such rare words was not that strict. So again, the scalability of this method is that we could use, like, it can be scaled up for another language as well, as long as considering the fact that we used the Google Translate API. So well, apart from Hindi and English, say you need other languages like perhaps Bengali or Marathi, we could do the same for them as well. And again, what makes it different from others is that in the sentiment analysis model, we have used emojis to improve our accuracy. And we have incorporated brand names. The brand names are treated as a specific separate feature in our model, which are extracted from the text so that, we get a better accuracy. And the use of Google AI, of course, it has been trained on the C4 dataset, which actually really, the T5 model, which really boosted up our accuracy on that one. So the results for our model are shown below. The F1 score for theme classification was around 93%. The average similarity score was a bit low at 27%, but again, the brand identification worked really well for us at 76%. The F1 score for sentiments was around 38% for us, and a final performance score was 65%. So that's all from us. Thank you.
Thank you, Anshul. So now we will begin the Q&A part. Judges, please ask questions.
Am I audible? Yeah, question from my side is you have used for the translation of the text, right? Like the text which are in Hindi or into English using the Google API. Outside that, any other translating or any other capabilities you have thought or tried out during this whole exercise?
We initially tried to train our model on the Hindi as itself, but there were several challenges on the Hindi. We couldn't get a good data set as well. We couldn't get good stopwords as well. Problem was even if we were getting stopwords, they had some grammar mistakes, so we couldn't match that. And so it was also a problem, and there was also a problem in lemmatization as well. We didn't have uh, good data set either, or good pipeline, pre-trained pipeline which could be used. So we tried training our model on the Hindi itself, but that was a great challenging task. So we went ahead with the Google AI. Moreover, Google AI also gives scalability. We can extend our model to other languages as well, because we also do not have to tell about the language. Google AI detects the language itself, so we can extend the model to all the languages which are there in the Google AI.
So if you tomorrow don't, let's say you have been asked not to use Google AI or any Google related API translators, anything else that you can think of that will fit in your approach, or you will, how do you think about it? Like this approach will not work.
Hello, can you repeat the question?
Yeah. So what I was saying is basically tomorrow, if we tell you that let's not leverage Google API translators or anything with Google AI, then do you think is there other way you can kind of think of the solution, or is it completely based on your Google AI as the the primary or the key fundamental block of your solution?
Though Google AI forms an important part of our solution, but yes, we can use other things as well. We have some models, but we have some open source libraries for the Hindi, English, analytical libraries for all the Indian languages, but that do not give that much accuracy. So our accuracy will drop if we use other open source libraries. So that's why we used Google Translate.
Okay, I'm good.
Okay. So am I audible?
Yes,
Yes,
Gupti.
yes.
Yeah. So my question is regarding brand identification. So you have quoted that you have got a decent performance for identification of brands. First of all, have you created any repository or dictionary of brands? What is your approach for that? I didn't find it in slides.
We used a mixed kind of approach. We used species part of speech tagging, which tells about the if a certain word is of it has a tag organization. So we used that, and we also made a dictionary which had the list, because we observed in the data set that the brand names are not fictitious, they are of the real world. So uh, we used a dictionary, we made a lookup list, and we also used the uh, organization tag of specie.
Okay. So what is the reason for the decline in, for example, brand sentiment, you know, model, which is basically you're quoting that is F1 score is around 36%. What happened there?
I think one reason for that could be the fact that we only considered adjectives that were close to the brand as we specified in the model. While we found it to be easier, we couldn't implement it for, say, contextualizing adjectives that could be sort of placed further to a brand in a sentence or a paragraph. So I think that could be one reason why we have a lower score in that parameter.
So I also see that you have placed all your modules in a very kind of a series fashion, right? One module output feeding to the other. So if you have a lower accuracy in, let's say, one of them, would that not impact the pipeline downstream?
No, no. We we have shown that in a pipeline fashion, but it wasn't that much pipelined. We kind of integrated the all the models in the last. The first task force of pre-processing, we took its output and fed it into all of our models. So our theme classifier model was independent. Then when we get if some model is if some tweet or article is of mobile, then we have applied uh, brand identification, and with the brand identification extracted the context of that brand, as Anshul said. So we fed that into the sentiment analysis, and for uh, because we had to do headline generation on articles only, so we kind of adopted somewhat different approach, where we trimmed the articles, because what we see in the articles, the because we use the text summarization approach, we have main crux of the article in the initial words only, and the rest part of the article is just an extension, and it gives much broader details of the article. So we used initial 120 words, and if we did the trimming, we removed if we didn't do the trimming, we rare words, but if we did the trimming, we didn't did that extensively.
Okay. Akash, do you want to ask anything? I think then in that case, Soumya, we are good from our side.
Okay, sir. So thank
Thanks.
you, everyone. So judges are like, you want to take a lunch break, or are we good to go for the presentation?
I would want opinion from others. Maybe one more round. Glenn, if you want to comment here.
Hello? Hello?
Yeah, Soumya, just give us probably maybe 2 minutes. We are coming back. Most likely, we will have one more round, and then we can have a break.
Okay, sir. Sir, tell me when you want to proceed, okay?
Sure.
Hey, Soumya, we'll go with one more and then take a break. And we are swapping. Yes, Jaskaran is there. We are good.
Jaskaran sir, please rejoin. There is some issue.
Hey, Soumya, we are good to go.
Yes, Soumya.
Okay, sir, can we proceed?
Yes, yes.
So the team
Next team.
members of team 19, please raise your hands. So
Hello.
anyone else is coming or shall
No,
we?
with here.
Okay, we can start now.
Uh,
Okay.
I'm audible, right? Let me share my screen.
Yes.
Is my screen visible?
No, not yet. Okay, now it is visible.
Hello everyone. I'm Dhananjay and I will be presenting approach of our team number 90. At this point, I think everyone is familiar with our problem setting. So let me get straight to our overview of our solution. First step is theme classification. We identify the theme of the text, both articles and as well as tweet, using a binary classification model. The model is language independent, i.e. we have a single model for all the three languages in the dataset. Second step is translation. We detect the language of the text that was classified as positive in the first step, and we then translate the non-English text into English. We translate only the positive text as we don't need the negative text. In the third step, we use a transformer-based BART large CNN model for headline generation on the translated English articles. And in the last part, we have already pre-extracted the list of brands from the training dataset. We check the mentions of these brands in the incoming text and return the sentiment of the brand using sentiment of the sentences that has the mentions. The first subpart is classification. The task at its core is a simple binary classification problem. The data we have has multiple languages, but as we know, language detection and translation can be very slow. So the model to make this classification should be fast and in real world should be able to handle large volume of incoming data. For example, stream of tweets, which is a usual use case for this type of analysis. We feel like to classify the text is related to mobile tech or not, We need not have good understanding of the language. If text have few keywords, it is very likely that text is related to mobile tech. And these keywords can be in any language. So we have decided to train a single model for all the languages. So the model is easily scalable in terms of languages. We tried various models, including some transformer-based model, but our final model is a simple logistic regression model. We have chosen it due to its simplicity. The performance was nearly on par with other models we have tried, but with other benefits like speed and simplicity. Features for this model are counts of various n-grams occurring in the text, n equals 1 for tweets and n equals 1 and 2 for articles. Due to the simplicity of model, we can do inferences about 10,000 tweets per second, which is very fast. And because the problem is not that and the performance was on par with the transformer-based model, we have decided to go with simpler, faster logistic regression model. Now Agraj will talk about headline generation.
Okay, so the headline generation task involved 3 subtasks for us. It was about detection of the language of the sample, translation to English in case it was non-English, and then the final summarization. So for the first stage, we used a language detection library called LangDetect, which was a direct port of the Java framework developed by Google for the same task. And it uses 4-length character tokens, which it matches against a table of language features from its database in order to detect languages. Now, the reason for us separating this task from the actual translation through the Google Web API was that we basically observed a very significant boost in speed if we gave the translator the language as an input rather than asking the API to detect it by itself. And since we were constrained to working with the free version of the Translate Web API, we segmented articles which were exceeding the max limit size into smaller chunks and processed them individually before concatenating the outputs. Now, coming to the core task of headline generation, due to the size of the data set we presented, we decided to go with a pre-trained model from the Hugging Face library. We tried pretty much every abstractive method. Apologies for the typo on the slide. We looked into abstractive text summarization. We tried a bunch of models which supported the same task within the Hugging Face library and finalized the Bartlett CNN due to a significant boost in performance compared to the other models at a small cost on time complexity. And as you can see, the scores for the evaluation of the training set are at the floor of the slide here. The last thing I'd like to cover is the fact that we went exclusively with abstractive text summarization because, for an example, like headline generation, we needed the semantic view of the entire article. And extractive text summarization, on the other hand, would have essentially just picked out sentences which it considered to be important to the core of the article and left out certain chunks. With that said, I think that about concludes the headline generation task. I will hand over the mic to Dhananjay for the rest of the presentation.
The next subtask has a distinctly unsupervised problem setting. So we don't know the brands in the text beforehand. We did not want to inject our knowledge of smartphone brand. So we first decided to extract a list of mobile brands from the English training data set itself. We already have classified the text is mobile related or not, and we have reused the translation from the headline generation task. We check if the brands from the list is in the text using regex search. Then we separate the sentences that mentions this brand and output the average sentiment of the sentences as the sentiment of this brand. To extract the brands from the given training set, we use state-of-the-art named entity recognition model. Instead of more traditional rule-based NER models, we decided to use a transformer-based model. This model is based on Roberta base and is from the latest Spacey library. On the right, you can see that the top few brands detected by this model in the training set. As we can see, most of these are actual smartphone brands, and we don't hard code anything, so that's good. So we run this model on training set and save the top detected brands, k equals 26 in our case. And we also use the text block library for the sentiments of the sentences. Do note that the NER model is on training dataset only and is not needed at the time of inference. The inference consists of string matching and is very fast. So the comment we got that our model is slow, but in reality the inference is pretty quick. Here are a few highlights of the approach. The classification model is fast and language agnostic. We did not need to detect the language or translate the text before classifying. We have used Bart's CNN model for headline generation task. We have used a state-of-the-art transformer-based NER model to detect the brands from the training dataset itself. We didn't hard-code any known brands. Brand identification and sentiment analysis at the time of inference is also fast, and we did not have any multi-models, which are typically bigger and not that performant on non-English languages. The brand detection and analysis part is highly portable and can easily be rerun on different domains other than mobile tech. Thank you. We are ready to take any questions you may have.
So one question from my side. You said that you have leveraged the NER model, right? During your training, NER during your training dataset, correct? And after that, while drawing the inference, you were using the string matching, correct?
Yes.
So, what I'm trying to understand that when you say that while drawing inference, you are using the string matching. Is the corpus that you are using there is based on, let's say, all the generated output from the NER model?
The string matching is done on the incoming test tweet or article, right? So we have a set of brand names taken from the training data set, and we search for each brand in the incoming test set article or tweet using regex match.
No. So what I'm trying to understand then finally, how are you connecting that NER piece into the inference into the inference drawing?
So we used the NER model to get the list of brands. So we didn't hard code or scrape the brands.
Got it. So that means that the corpus that you are figuring out from your NER model is the list of the brands which is from your training data, right?
Yes. So
right. So now when in the let's say validation data, if some new brands come, right, how will the string match work?
So it will not work because it's unlikely that we will have a new brand of mobiles, and given that the setting of this problem is unsupervised, we didn't have any labeled data set for sentiment as well as brands, so this is a good enough compromise that we think.
To add to Dhananjay's comment, so here the assumption is the training data and the whatever data which will be coming, they are kind of similar. If it is too different, then it will be problem.
So I mean the assumptions then that you have taken is basically the training data will kind of become a superset of any kind of test data or validation data going forward that may come, right?
One other look at it, that is correct in some sense, but let's say you have a larger, let's say right now you have 100 training samples and tomorrow you have 200 more. So what you have to do is basically include that 200 along with this 100 and retrain the NER model once again, and you extract the list of model names, and then once that is done, again you can throw away the model and come up with
so you will keep on reiterating and keep on increasing the list of your training data. That's what you are saying, right?
Correct.
Just adding to that, the intuition there is that in our case, because we're detecting mobile brands, the number of mobile actually have to look for won't rapidly evolve. So the hope is that the NER model doesn't have to be retrained quite frequently, and hence won't be a bottleneck.
What's the computational efficiency of your NER model?
It's a ON square model, but it will take around 2 hours on the given data set. That's mainly because it's not currently running on GPU because of the library limitations. But if we have GPU access, then it will be quick enough. And the main motivation for that is we can rerun the same code on a different domain articles. Let's say we want to run on the cars articles. We can rerun the same code, get the brands of the car, and get the sentiment of this car in the car articles instead of hard coding the mobile brands.
Okay, I'm good from my side. Thank you.
So I understood you took text block to identify sentiments, but how did you connect the sentiment for a brand? Say if there are two brands mentioned in an article, how did you connect?
So we extract the sentences having the mentions of the brand. So if a brand is mentioned on, let's say, 5 sentences, the sentiment of the brand would be the average sentiment of these 5 sentences. And having two brands in the same sentences is quite low, and also the problem setting doesn't allow us to train like brand specific sentiment analysis.
So you're saying basically the current solution will not work if we have two brands called out in one single sentence.
It will work, but the that sentiment of that sentence would be associated with both the brands and will average out with the other sentences of each of these brands.
So the performance would be low, basically.
I would say, like, just to clarify one more thing, like, let's say 1, 2, 3, 4, 5 sentences are there, and out of these 5, like, sentence 3 has 2 brands. So, and like one brand occurs in sentence 3 and 5, and another brand occurs in 1, 2, 3, both, right? So, for sentence number 3 will be counted against both the brands, but whereas the sentence number 1, 2, or 4 and 5 will be counted against only one of the brands, not.
And we average out at the article level. So if the general sentiment of the article should be positive or negative or neutral about the brand, that's the prediction.
And did you handle anything? I mean, did you handle any sarcastic comment? I mean, say suppose one certain tweet is sarcastic. How are you handling that sort of scenario? Because text block, as far as I know, cannot handle that very efficiently.
No, we haven't handled that.
I think like detecting sarcasm is one of the like prominent challenges in NLP itself. So it is not easy. So we thought like, okay, that will be like too much big problem to solve in this current scenario.
Okay, got it. I'm good. Kirti, you have?
Yeah. So I was curiosity is around your BART large CNN model. Is it a pre-trained you're using for scoring for both English, Hindi, and English? Do you find any edge cases? Did you find any edge cases?
So given the size of the data set that we had, we felt like we had to go with a pre-trained model. It was about just 4,000 articles, and once you filter out the non-mobile tech articles, there's very little left to work with on a training standpoint, and that was our reason for going with the pre-trained model. As far as edge cases are concerned, one thing we probably looked in hindsight, one thing we could have probably done better is with the translation part of that pipeline. So if you look through the code, it only detects the major language, and based on whether that's majorly English, it doesn't really put the article through a classifier. Whereas if we'd segmented the article and looked at many pieces, especially in the English cases, we probably would have gotten a more uniform translation and a slightly better performance on the data.
Got it. Good. No more questions from my side. Thank you.
Thank you, everyone. So we will be taking a break. Judges, what is the duration or when you want to resume? Hello?
How much time are we allowed to have a break?
Shall we resume at 2 o'clock?
2. Okay.
45 minutes.
So we will start at 2.
Yes. Soumya, during that time, please give the speaker access to Rajni.
Okay.
For my.
Okay. Yeah, sure.
Yes, Soumya, we'll be back by 2. Yeah, Kirti is here.
Yes.
Hey, Soumya. Hi, Soumya.
Hello, sir. Hello, sir.
Yeah, we are good.
Okay.
We can
Yeah.
start.
So, team members of Team 14, please raise your hands. Hello. So, anyone else is going to come, or we can start?
We are ready to present our presentations. So
Okay. So you can.
let us know when to start.
Yeah. You can start. Hello, Aryan. Hello.
Hello, am I audible?
Yeah, you are audible. You can present your screen.
Yes, yes. Come on. So is my screen visible? Vardhan?
Yes. Yes, it's
Yes, Aryan, it's visible.
Okay, so good afternoon, everyone. We, the members of the Team 14, we would like to present our solution for the Bridgei2i high-level problem statement. So basically, this problem statement demanded us to develop a system to identify the theme of tweets and articles which have been collected from web scraping. And if the theme is related to mobile technology, then we had to identify the brands contained within those specific tweets and articles, and then classify the sentiments of those brands, which are basically aspects. And then we also had to generate a one sentence headline for the articles having mobile centric tweets. So this is a approach we took to solve this problem. So basically, we took the data set, pre-processed and cleaned it through various codes and libraries, and then we put it into a translation module wherein we translated all the points of the data set to English, and then we performed the sentiment analysis of the same through our distributed transformer model. And if the tweets were mobile centric, then we divided our job into two subtasks. First was aspect with sentiment analysis, uh, uh, wherein we extracted the brands and classified the sentiments. And on the other hand, we generated the headlines using a transformer model pre-trained for summarization for the articles which had mobile centric tweets. So throughout our whole course of solution, we preferred the transformer architecture for our all the tasks involving natural language processing. This is because of two basic reasons. Firstly, they are better to process long range dependencies for the text and all. And secondly, they have incorporate a various of attention mechanisms such as multi-rate attention and self attention. So, which makes them superior than their counterparts RNN and LSTMs, just because the fact that they can see the entire input sequence rather than processing them token by token in a sequential manner. So our first job was to pre-process the data set, and So we process the articles and the tweets separately, depending on the ID of the data point in the corpus. So basically, for the articles, we remove the HTML tags and URL links, and we also put a constraint to remove the irrelevant information, such as the designations of the author and the places and all those irrelevant information which creeped into the dataset due to web scraping. And also we discarded noisy articles wherein there was a repetition of some special characters over a long seed length. And for the tweets, we removed this Twitter-specific lexicals such as retweets and mentions, and we removed the reserved ones, URL links, and empty placeholders. So this was a basic pre-processing. Then we put all our data points into a translation module. So the translation was done using the Google Translate API through a library. So the reason why we choose Google Translate is because it supports 100+ languages, hence taking of multilingual text in the dataset. And since our dataset consisted of languages such as Hindi, English, and Urdu, so it efficiently took care of that. We also thought of using the current transformer-based models, such as the Facebook state-of-the-art M2M100, but we found that the inference speed for the same was quite less. So therefore, we thought of going with this Google Translate API just because of the fact that it has a very quick inference speed and is suited for large and can easily process large sequences. Now, coming out to our main task, which was a sentiment classification. So we use the Distilbert model for this task, and the reason why we use Distilbert is because it is efficient, fast, and lightweight, and contains quite less of parameters. At the same time, this translates to quicker training times than the original BERT and its other modifications, while retaining most of the accuracy of the BERT model. So here is a chart explaining the same. We compared 4 models, and we saw that Distilbert takes 4 times less than that of the original BERT model, with a minor degradation in performance, which can be acceptable. So this allows scalability for large data sets, and at the same time, it can be efficiently used for edge computing based tasks. So after we took a pre-trained model which was trained on the Wikidata dataset, and then we did a fine-tune training using the Keras framework, using an 80-20 split, and the accuracy is as mentioned, which was quite good considering the fact that we had a small size of dataset, and the training time was quite small, coming out to a paltry 2.35 minutes. So after this, we performed divided our whole approach into 2 tasks, such as the headline generation and the aspect-based sentiment analysis. So basically, for the sentiment-based analysis, we use the Python package for the same because it echoed the exact things we wanted to implement in a solution. So basically, this whole thing is built upon the Adabert model, which has been trained in 2 specific steps. First is it is trained via self-supervised training on the dataset, and then it is further in the second step it is fully trained via full supervised training on the specific tasks. And the whole pipeline for this process can be divided into these parts: pre-process, tokenize, import, predict, review. So the pre-processing part basically converts the inputs into the required method. So basically we need to feed in the aspect entities into this along with the text, and it then pre-processes it and creates a tuple of the aspect entities and the text, and then feeds into the BERT model for further processing. And these tokenized encode predict are the basic, what we can say, the basic ethos of the BERT model per se. But the most startling fact about this process is the review and post-process parts given in this whole workflow. Now, this review and post-process is done by a specific model known as the professor, which is actually comprising of auxiliary models and codes which supervise the model learning and helps it to discard or correct the suspicious predictions produced by the model. Now this is quite relevant owing to the fact that this can be used to effectively monitor our model during when it is deployed to the end user. And yes, we so basically how we proceeded was that we took a specific corpus of the brand names fetched from a website, and then we searched for a window of characters within the article to relating to the sentiment, and the process took a mere 4.25 minutes to complete the whole task on the entire testing data set. So, considering the small iteration time and proficiency of ABSA to start gathering information, this approach is scalable and efficient. Also, I would like to state in this that the labels for the aspect-based classification were not provided. So, if they would have been provided, we could have further fine-tuned the BERT ADA model on the same, and we would have obtained much better results for the same. So, now I would like to call upon my friend Vardhan to elaborate on the headline generation task.
Hello, Aryan, am I audible?
Yes, yes.
Very good afternoon to respected all. And I would like to explain our approach on task 3, which was basically the headline generation. So the objective of this task was to generate automated headlines for the articles which were labeled as mobile centric. So basically we can realize the headline generation task as a sort of summarization based task where the output or the headline which we want to generate must be belong to a certain window of a maximum and minimum threshold value of characters. So for this task, we tested 4 transformer-based architecture. The first one was Pegasus. So Pegasus is a transformer-based encoder-decoder model. So in Pegasus, important sentences or phrases are removed from the input document and are generated as and are generated together as a complete output from the remaining text document. The most important feature of the Pegasus is that it can provide amazing results from even on small data sets. The second model we took was T5 model. So T5 is basically text-to-text transformer model. So it attempts to combine all downstream tasks into a text-to-text format. So in T5, the inputs are modeled in such a way that the model shall recognize a task, and the output is simply the text version of the expected outcome. Also, the T5 is trained on C4 dataset, which is quite a huge dataset. So the other two approaches are basically the addition of a BART layer with the above two mentioned models. So a BART is basically a denoising transform-based autoencoder model designed for pre-training sequence-to-sequence tasks. So the BART is trained by first perturbing the input text with arbitrary noise function and then learning the model to or generate the original text from that perturbed text. Though on testing, we found that T5 and Pegasus models as a standalone performed better than their respective combinations with the BART. Now, the T5 and Pegasus models were fine-tuned on the given corpora using torch libraries. The length of the decoder output was also modified as per requirement, while the encoder length was kept as maximum as the model can allow. Also, both the models were quite efficient with respect to the training time. We trained our models for 10 epochs, out of which Pegasus gave an average time per epoch of 17 minutes, while T5 gave an average time per epoch of 11 minutes. Also, the average time per inference time per translation, per example, translation is just 4.53 seconds. Finally, we chose Pegasus for this task owing to its standalone performance in 3 metrics, that is similarity, F1 score, and precision score on the testing data. We believe that this performance is based on the fact that the Pegasus model was pre-trained on a novel summarization specific objective called gap sentence generation. Now, I would like to highlight some advantages of our approach. So the first is that the approach is both scalable and efficient in nature, as it is evident from the low inference and training time. The second advantage is that the encoder and decoder length can be explicitly specified during the fine-tuning to adapt the dataset and the nature of the task. The third is that since the entire pipeline is based upon transformer architecture, which is superior to the conventional NLP methods for tasks involving conditional generation. Also, the pre-trained model-specific tokenizer takes care of basic preprocessing such as removing punctuations, stop words, and other things. Now, we want to provide some suggestions that can further improve our model for real-time deployment. So the
first suggestion is that the use of long form model. So a long form model can capture long range dependencies for extremely large sequences. Also, the current state of the art long form model can capture dependencies as long as up to 4096 characters, which is quite large as compared to 512 for both Pegasus and T5. Second point is I want to mention is that for the translation of multilingual data, paid version of Google Translate API can also be used, as the free version only allows a particular number of requests to be sent to the server. For the third point we want to suggest is that we can fine-tune our Adabart model on the custom data set for the aspect-based sentiment classification to accurately capture long.
I believe his my friend's network has down, so I'll explain the rest. So basically, as I stated earlier, we can fine tune the Adabart model on a custom dataset to improve the performance. Basically, this will allow us to, since it is because of the fact that the Adabart model which we used was pre-trained on a specific corpus relating to restaurant and laptop reviews. So if we had the label data set given to us, then we could have trained Adabart on the same, and then this would greatly enhance the classification of the aspect entities, which are the mobile brands in this given problem statement. So with this, we would like to end our presentation, and we are open to questions and comments. Thank you.
Thank you.
Pardon me. I think I was disconnected because of internet issues.
Okay. Like, so we will begin the Q&A round. Judges, please ask your questions.
Maybe I can go first. First of all, am I audible?
Yes, ma'am.
Okay, great. Of course, there'll be a few more questions from Kirti and Jasfaran. I had a very simple question that is on pre-processing. You said you have removed author's information. So number one, why did you do that? Because, let's say an article or a tweet is from Tom Cook, probably that will give you the brand information. And number two is, how did you identify this author's information for removal?
Ma'am, basically, we felt that the author information is not very useful for classifying mobile-centric tweets because, as you stated, if I take the example of Tim Cook, so he can comment on any other topic which is entirely not related to the mobile-centric scenario. So that is why we did not consider taking the author's information for the same. And second is that we first went through the whole data set and we saw that mostly the initial part of the data set, which is the first line, contained the writers or authors information and other unimportant tasks which had crept in during the web scraping process. So we kept a threshold as to if our first line is less than this many characters or less than this many words, so we would just remove that line and process the rest of the data set further for sentiment classification. So this type of stringent pre-processing allowed us to just neglect those things which may interfere with the exact classification which you wanted.
Sure, Aryan. Do you think this is scalable, at least in terms of the examples that we are discussing?
Ma'am, as far as I consider that for articles generally, most of them had this characteristic that if they contained some unimportant information such as those from web scraping, so the first line was very short as compared to those articles which had a sizable amount of content. So we thought that removing the first line would not deal as much harm to the model as and would not basically affect the runtime as much as we expected. We think it to be. And secondly, we are not doing this for tweets because the tweets are in itself very short. So there's no point in putting this harsh constraint for them. So that's
Understood.
what I
Thank
think.
you, Aryan.
So, hi. I need some idea from you guys. So basically, you're talking about fine tuning the Adabert model and the data which you have used as the laptop training and restaurant data, which I think I'm aware of, has the label at a token level as well, right? Correct, Aryan?
Yes, sir.
So in this scenario, getting a data which is at that granular, labeled at that level is definitely difficult, right? So what would you suggest? What could be the hack here to actually get a data labeled for the brands easily?
So for this, I propose that firstly, the if we are taking the pre-trained BERT model, firstly we need to take the pre-trained BERT model, which is trained on mass language modeling. So after that, first we have to for a specific entity, we first search, we first determine to what portions of the, we first do a basic naive sentiment classification, that how it is classifying. The whole sentence, it is positive or negative. And then what we can do here to impel upon the model to perform aspect based classification is that for a given aspect, if it is found in the input sequence, we calculate the attention with respect to that aspect across the whole sequence and search to which portions of the whole text it is giving the most attention. And according to that, we can put a window around it of about, say, minus 250 to 250 characters or less, and then we can extract that thing, and then we can classify that sequence which we had extracted from the window.
My question was a little different, Aryan. My question was, how will you enable easier tagging of, say, tomorrow I get new data, right? But I can't keep on tagging at a token level. It's very tedious.
So this thing with my approach is basically stating that we are firstly allowing the model to tag its own, to tag the labels on its own.
Okay.
So when we are putting this constraint that we are depending on the attention it is giving to different parts of the sequence for a given aspect, so the model is and we are extracting that part of the sequence for classification. So basically the model is giving its own is predicting the own labels as it is trained on the sentiment classification task. We can easily impel upon the model to find the sentiment for a given part of the sequence, which we calculated using the attentions, using the window which we found out from the attention given for a certain aspect to the whole sequence. So once we have the labels predicted by the model, then we can we already have most of our job done. We just now need to now review the labels if they are correctly predicted or not, and then we can happily train it our Adabert model for this task.
Okay, got it.
Yeah. So I see in the different objectives you have given a lot of focus on the text summarization with so many approaches. Do you also have some benchmark results for those approaches, or how do you arrive at, let's say, the finalized approach for text summarization?
Sir, we, with respect to the training data, we ran all the four model architectures on the same, and we obtained a matrix for which contained different metrics for the same model, and that were we included in a report also. So depending on that, we found that the Pegasus was giving us a higher metric for precision, similarity, and F score. So on the basis of that, we chose to go ahead with the Pegasus model.
Any specific reason why, you didn't move ahead with alternate approaches for your sentiment score, because which is not very high? What is the why did you, I would say, stop there with the current approach and didn't explore any other because the results were lower for the other compared to the other objectives?
So actually, to be quite honest, firstly we thought of using the long former architecture for our purpose. But as we went through the training process, we found that the GPU limits were constantly getting exceeded. The VRAM limits were constantly getting exceeded on the collab, and through the training module of the trainer module of the transformer library, we started pre-training, fine-tuning it, but the pre-training time exceeded quite a bit. It was coming out to be 2.5 hours for a single epoch. So that's why we felt that using the long former for a purpose would have yield better results because the article length was quite large. It was much greater than three. It was the mean length was around 4,500 characters. So for that, we feel that if we would have had the possibility of using the long former, had we given enough available resources, we would have achieved quite good results.
Okay. Any further question from the? I think I'm good.
We are good, Soumya.
Okay, thank you everyone. So can we proceed to the next presentation?
Thank
Can
you.
you give us 2 minutes?
Yes, sure.
Sumit, just give us 5 minutes. Yeah. Soumya, we can go ahead.
Okay, sir. So a participant of team number 21, please raise your hand. Abhijit, anyone else is coming or we can start?
My other team member is joining.
Okay.
Piyush Goyal.
Hi everyone, can anyone confirm that I am audible?
Yes, you are audible.
Hey guys, got disconnected.
Thanks, Soumya. Is my screen visible?
Yeah.
Thanks again. So, hi to all. We are team number 20 and we are presenting a solution for the Bridgei2i automatic headline and sentiment generator. So, as all my fellow teams highlighted, the problem statement consisted of three parts. The first one was identifying the theme of an article or a tweet. The second was to identify the sentiment against each brand in case the theme of the tweet or the article was mobile tech. And the third one was to generate a single line heading, one single sentence of heading for each article if the theme was mobile tech. So we were given a data set of 4,000 newspaper articles and 4,000 tweets. There were multiple challenges with pre-processing the data. Firstly, we had to process the retweets and quote tweets and convert them into format by removing keywords like RT and punctuation marks. The data had special symbols, links, and other metadata, which was replaced with blank spaces. Then there were hashtags, of course, which we dealt about removing the hashtag symbol. I would like to highlight upon the fact that we have not removed the sentence or the statement after the hashtag. We have only removed the hashtag symbol because in that case we might have lost some information which was earlier present. Astonishingly, we retained the emojis as this significantly improved the sentimental analysis as we will describe in the upcoming slides. We also retained the negation words and made sure they are not removed like the other stop words because we know that a few negative words can completely alter the meaning of a statement. Finally, we also retained the full stops as they helped in sentence segmentation. I would also like to highlight that some of the tweets were single line and we had explicitly taken care to add a full stop wherever necessary. The next challenge was to deal with multilingual data. The dataset consisted of tweets in Hindi as well as in English. Apart from English, we need to first homogenize this data. So the very first task was to identify which language the data was present in. We have done this task using k-means clustering. The similarity metric that we have used was Levenshtein distance. Levenshtein distance is a string metric for measuring the difference between two word sequences. The next step was to translate this sequence of English to English or to Hindi, and which can then be translated into English. For this transliteration, we have taken the help of a PyIndic translate library of Python, and this has done our work quite efficiently. Then we need to translate our Hindi text to English. We searched for open source translators, but none of them could actually provide satisfactory results. We didn't want to use Google APIs because it was a paid API. Also, it was out of the spirit of this competition, which clearly mentioned that we could only use the open source APIs. So we actually discussed upon it and thought like, why couldn't we make our own translator? So we were actually able to find a good work corpus, which was openly available on one of our educational websites. And we have used a seek to seek model with attention techniques, which helped us to deal with large text compared to the LSTM model. Also, I would like to highlight why I have used this word pseudo translation, as we know that the seek to seek model with attention mechanism take a huge time to compute. So not to make it scalable, we have not explicitly spent computations on doing the translation, and we have just translated the words to their English words. We are not actually focusing more on the grammar thing because that is dealt by our upcoming sentiment analyzer. Also, we noticed that most of the brand names were actually in English. So we have exploited this fact and have modified our algo a little bit and tried to test it over the non-homogenized data itself. And we were very surprised that it also performed really well. So the next thing was to classify and identify the brands. So we actually scraped all the mobile brands and the mobile names from a review website, GSM Arena to be specific, and we were fortunate enough to get a data set of 150 brands and 3500 plus models. We then identified the brand names in the tweet using regex matching. So regex matching was used primarily because it's easily modifiable. In case you want to add a new brand, you just have to modify the list, enter the new brand name, and you are good to go. It is computationally cheaper as the data set was small, and we preferred stats over intuitions. So we were actually getting much higher accuracy with regex compared to the deep learning model that we were creating to identify brands. Uh, Finally, we for true negatives, which means that there might be some tweets that were actually tech tweets, but the regex matching could not find that these are the tech tweets. It could not identify the brand names. It might be due to the spelling error or something. We have built a SVM classifier for these true negatives, and this SVM classifier has been provided with a soft margin. So this really helped us to get deal with the words like Xiaomi that starts with an S and not with a X. So that was it. And also one more thing, we actually scraped all the a good amount of mobile articles, and we have also gone through the dataset provided to us, and we have identified which are the most frequently occurring words, and those words were actually converted into a dictionary, and we have used them for regex matching, which in turn helped us to identify if this article or a tweet is mobile tech based or not. So I would like to invite Abhijit for the rest of the presentation.
Now comes the headline generation. So we used text ranking algorithm for it. So we had original document. So it contained many sentences and keywords. So first of all, we extracted the keywords, then the sentences. The sentences, as Piyush earlier said, that they were we didn't replace the full stops. So they were used to segregate the sentences, and then we transformed the sentences into vectors, and then allowed text ranking algorithm to run on it. So we received sentence rankings using it. So it actually finds the most relevant sentences and uses it to summarize the text. So we achieved pretty decent score on it, 38% matching accuracy on headline generation, matching score on headline generation. And next. So the last thing was to identify sentiments for each brand. So here we tried two different approaches. So first of all, what we did was we used TF-IDF score here. Since we were, as Piyush said earlier, when we were translating, we called it pseudo translation. Since we were saving time to not take care of the grammar, so the words were translated in our final form, and then since for those sort of text, TF-IDF works well. So first of all, we identified most relevant sentences for a brand, because in a tweet or say in an article there may be multiple brands present, but when we are going to identify a sentiment for the brand, we need to find which sentence this corresponds to. So we use TF-IDF scores to match those sentences to the brand, and then since we had only 3 sentiments in which we have to classify all the articles or tweets, so we again use TF-IDF scores to find which of these sentences which of this sentiment matches to the which of the sentiment matches to that sentence which has been corresponded by the brand. So basically we were able to find calculate maximum of this negative, positive, or neutral TF-IDF score against the sentence, and then we found the sentiment for a brand. But there was problem because we were not taking care of the grammar. So so TF-IDF scores sometimes deceives you when there are negative words also present there. So in case of negative words, we so there are for a language there are a list of negative words. So we use those negative words. Like first of all, we ran our algorithm without doing treating negative words separately. Then we introduced how we could use those negative words to identify some of the sentiments which are negative. Then we achieved better accuracy. Uh, so so this was about our finding sentiment for each brand, and hence our pre-processing, which we were using secretively doing pre-processing, helped us in later in sentiment analysis. So next slide. So in conclusion, so the main doing this analysis, we found that the brand, first of all thing was brand names were in English, so the brand identification became easier by string matching, and then the sentiment analysis became down to finding collection of words in sentences, because we were using TF-IDF scores and we were not completely translating the sentences. And we haven't used any very heavy model over here. Like we tried using those models, but they were like they were taking much time to train. So we use very light models here, and if so, they gave us good score, particularly in the headline formation, and then also using punctuation and emojis helped us in sentiment analysis. So that would be all from us. So we could start the Q&A round.
Okay, thank you. So the Q&A round will begin. Judges, please ask your questions.
Okay. Go ahead, Rajni, if you want.
Sure, I will follow the pattern. I'll go first. Thank you so much, Jaskaran. I think good presentation, team. Very well structured. There are a couple of questions that I have, but I'll ask one and then see how time allows to, get to the other simpler question. But the question that I would ask at this point is around headline generation. So you use text ranking similarity metric. So I was wondering, what did you do when there are more than expected sentences are coming with top similarity? So how do you then reduce to the 100 tokens or 100 words that we expect?
So, ma'am, there may be many sentences which may be relevant for which may have high ranking scores, but then there is we usually took 3 or 4 sentences in tweets, because tweets had less sentences, and for articles we used to take 10 sentences to form the final summary of 20 words. So that how we catered this issue, because if we are treating articles and tweets as same, then there would be a problem, because tweets are usually containing very
Absolutely. What if in your top 10 there are ties in terms of the text rank score?
So, ma'am, our algorithm, if there are ties, it takes whichever is present first. So it doesn't do any further thing on it. We could also think we could have done that, but in our approach, we haven't did anything with that.
Understood, Abhijit.
Because, ma'am, since the sentences, in our analysis, when we used to print those ranking scores, they were usually very different, but we didn't came across very similar examples. That's why our mind didn't went in that direction that we.
Understood, Abhijit. Thank you so much. I'll come back if there is more time. But over to you, Jaskaran.
Okay. So you have used some sort of TF-IDF vectors to connect the brand identified with the sentiment. So what do you think? Where in what scenarios can that go wrong? Was I audible?
I think Abhijit lost connection. Piyush or anybody else want to take this question up?
Ma'am, I'm extremely sorry. Actually, I have not much idea about that part. Maybe Abhijit can answer it when he comes back.
Okay.
Maybe we can proceed to the next question.
Okay. Prinkan, you want to ask something specific?
Yeah. Hey, thanks, folks. I just wanted to understand this entire workflow or pipeline that you guys have in terms of classification and sentiment scoring, etc. Which part of the pipeline is more compute intensive or more time taking?
Yes. So as I highlighted, that we have used two approaches. The one consisted of the translation thing, and the other consisted of using the known homogenized data. So in case of the translation part, the translation time was the maximum which we were having, and that is what one was the reason that we have not worked upon the grammar. We have just translated the words. And for the non-homogenized part, sir, the sentiment analyzer was the most time-taking part.
Okay, and do you have any idea that how you can tackle optimize the performance there? Have you compared your your algorithm's performance with the standard benchmarks, if any?
Yes, sir. So we actually compared our performance with the BART algorithm, and not to mention again that the BART uses a hell lot of space compared to our TF-IDF algorithm. Also, like our computations were way more cheaper than the BART itself.
Okay. Okay, just can take it.
Abhishek, are you here?
I'm good. I just had that question. So wanted some more clarity on that area.
Yeah, just a second.
Rajni, you have, I mean, since we have time, you had some extra questions you want to?
Yes, just Karan, but I guess this is again related to a little bit of more clarity on how emoji has been used to identify the sentiment. So would like to know more, because in one sentence, if there are multiple emojis, then how are we handling that? And there was not much detail given on the presentation. So if team can talk about it, that will be great. Piyush, do you think you'll be able to help us on this question?
Yeah, ma'am, slightly. When we have actually used a Python module called emoticon, and it actually helps us to convert the emojis to ASCII characters. And from there on, in the sentiment analyzer, what I think Abhijit had been done is to um, give a good weight over those words. And we know that a few words can classify wrong, but a good emoticon would help us to get a sentiment way better than a few ASCII words. So that is what I think Abhijit would have done.
Got it. My question was a little
I'm sorry.
on the detail of some of those tags and some of the challenges that you might have faced.
Yeah,
But
Abhijit is back. I think he can answer now. Abhijit?
Okay, great.
You are
Sorry,
on
what? I was disconnected.
No problem, Abhijit. Maybe Jaskaran, I can go with my question and then we'll come back to you. So Abhijit, we were discussing on understanding the emoji, taking help of emojis to understand the sentiment.
Yes, ma'am.
Right, and talk about a little bit of challenge that you might have faced, because maybe one sentence can have multiple emojis and different kinds of emojis. So how did you handle that?
So, ma'am, they are treated like a normal text. So, if there is a happy or sad emoji, so it or angry emoji, so they are converted. Let me go. Yeah, so they are converted into our text. So our since our model was using text as input and emojis was converted into text, so it wasn't posing any problem. Instead, it was helping our model. So you were talking about multiple. So, ma'am, in when we are using TF-IDF approach to identify the sentiments, then they just add ups. Like if there are multiple emojis, they would just add up for a particular, say, positive sentiments. Then the emojis which we are using, say, happy emoji, if there are many happy emoji or smiling emoji, they would just add up and increase our positive score. Instead, if we are using angry emojis, so they go to the negative. They are more. They would more match to the negative score in TF-IDF. So then it sentiment would be negative. So we didn't explicitly remove multiple emojis because they were like
So,
they were useful. Yeah.
got it. So emojis as a text was part of your TF-IDF model.
Yes, ma'am. Yes, ma'am.
Understood. Just current.
Thank you, Raj. Okay. So, I mean, as explained earlier as well, you are using some kind of a TF-IDF vectorization to actually connect your brands with the sentiment. Am I right there?
Yes. Yes, sir. Yes, sir.
What do you think would be the challenge in this kind of an architecture?
So, sir, the main problem we face with TF-IDF is TF-IDF cannot take care of the sequences. Like if, like it usually it is advanced form of frequency of takes the frequency of the word. So if there are multiple brands present in the same sentences, and we are like uh, criticizing one brand and praising one brand in that sentences, then the TF-IDF would more match it to the neutral things instead of classifying both of those like both of those brand positive and negative. So since it is neutral, so the error is not so much because it becomes in middle. So that is challenge in the TF-IDF approach. But so we have used it because it is very faster than the models like BERT. So so that challenge is like there is a trade-off. Like if we could even use that thing here, or we could use just TF to uh, use neutral instead of positive and negative. And sometimes, sir, what happen is that in a single sentences there are more than 5 to 6 brands. Like a person is comparing those brands, so it is like it is pretty evident that when there are more than many brands, so they won't be specifying sentiments for all of them. So mostly they would be like these brands are launched, or just would be comparing that this phone is similar to like this are the competitors. So in that case, our model would say neutral. So 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 in is like it has benefits also. So when there are multiple brands, like sometimes in a sentence there are I saw 5 to 6 brands were mentioned there, and they were mostly neutral. So so TF-IDF helps in one place and also creates a problem, but in for the time it also saves the time of the algorithm. So that's why we use TF-IDF. We knew its limitations too.
Okay, got it. I think we are good.
Okay, thank you,
Soumya, I think we
Piyush and everyone. So, judges, please let me know when we have to start next presentation.
give us 5 minutes. We'll come back.
Hey Soumya, we can go ahead. Next team.
Okay, sir. So the member of team number 13, please raise your hand.
Next slide. Next organization है
कुछ भी डालना कोई
So anyone else is coming, or we can start? Okay.
Good afternoon, everyone. Am I audible? Hello. Yeah. So this is Team 13 presenting their approach on how we solve the problem of automatic headline and sentiment generator. So next slide, please. Yeah. So first we will be dwelling upon how we did the data pre-processing, and then we would be discussing how we approach each of the task given to us. So next slide. Yeah, so we were given a data set consisting of 4,000 tweets and 4,000 articles. So firstly, was the first step in our data pre-processing pipeline was removal of duplicate tweets. So on doing an exploratory data analysis, we found that there were 1,600 exact tweets given in the data set. And on further, like going through, skimming through the data set, we found that a lot of them were retweets as well. So we decided to remove the keywords such as QT, RTs that are present in the retweets. Also, so that the only the tweet contents remain. We also did one thing what we did was, like, there are a couple of @ and hashtags associated with the tweets. So we only decided to remove the symbol of @ and hashtags and retain the content associated with them. This was done because many people, while tweeting something, they tag the brands associated with like what they are tweeting about. So that may be helpful while recognizing the entities. And then we also remove the hyperlinks. And so using this, we were able to achieve get 2282 unique tweets. The second step in our data pre-processing was lemmatization. So the challenge here was, since we were given Hindi, English, and English language tweets, so the challenge was to find a lemmatizer which does the lemmatization for Hindi and English language. And when we pass English language to the lemmatizer, it doesn't affect the English words. So luckily we got a library named as Python library Stanza for doing so, and we were able to achieve this task, do pretty good on this task. And we decided not to go with stemming because stemming is based on just some kind of heuristics, and it chops off some stuffs from the last. So maybe if we pass through a English stemmer, Hindi and English words may get affected badly. And yeah, for the third part of our pre-processing pipeline was emoji support. So there was a kind of dicey situation whether to keep emojis or not. So we did train two different models for each task, with and without emojis. And at the end of the day, the conclusion that we obtained, like comparing on the performance of the model, like for sentiment analysis, emojis, like retaining emojis gave better results. And like this is also expected because many people express their emotions using emojis. And for rest of the other tasks, we decided to drop the emojis. And Yeah, so that's how we did the pre-processing. Now, next slide, please. So the first problem was mobile tech classifier, where we were asked to classify whether a tweet or an article talks about mobile tech. So next slide. So yeah, so the first thing for this is to convert the text as vectors. So we use the bag of words approach as our first um, shot. And what this does is that we get all the unique words in the corpus and assign each word an unique index. Then we create a vector of the dimension same as the size of the vocab that we obtained, and the entry at each dimension is the count of the word in the given tweet or article. Now, since text, tweets and articles can be of varying length, so we normalize the vector by dividing it by its L2 norm, and doing so, we obtain a vocabulary of 6,347 words. Next slide, please. So once we obtained these vectors, we trained a logistic regression classifier with 5-fold CV, and we achieved an accuracy of 98% on the first go. So that's good. But we wanted to see like if there is some kind of bias that our model faces, like is it the task that is so easy, or like whether the data set that the distribution from which the data set is picked is easy. So that's what we wanted to do. So next slide. So we identified a couple of problems. The first was high frequency words such as like mobile, smartphones, etc. Like the classifier was only learning like to whether if these words are present in the text, or it classifies as mobile uh, tech, and if these are not present, it classifies as non-mobile tech. And so what happens is that, let's say if we keep just a tweet, or let's say a food review, and keep at the end a word mobile, then it would classify it as a mobile tech. So it was not capturing the semantics well. Another was while skimming through the training data set, what was provided to us, we saw that non-mobile tech tweets were mostly from the politics domain. So let's say if at the test time we were provided with some other review, let's say clothes review or something like that, maybe the model would not generalize well. So these were the two problems. Next slide. Yeah, so for the first problem, we came up with two approaches to solve. The first was a TF-IDF vectorizer, and the second one was LSTM-based classifier with embeddings, word embeddings, and for the second one also the same LSTM classifier with word embeddings. I will talk about these in details in the next few slides. So TF-IDF vectorizer. So, like the words like smartphone and mobile, these are important for classifying a tweet as or a text as article as mobile tech, and at the same time, we can't remove these words also, just like because they are high frequency. So TF-IDF vectorizer tries to bring the way out between them by normalizing the frequency of the words in each document. So we have presented the formula also for here, like TF is the term frequency and the log of this thing is the inverse document frequency. So next slide, please. Yeah. Second thing was capturing the semantics. So like BERT models, LSTM models, since they are sequential models, they're able to capture the semantics well. So the architecture that we used was like first pass the input to sentence to a pre-trained BERT model and get the word embeddings in 768 dimensions and pass these word embeddings to an LSTM, which acts as like an encoder, or you can say. And yeah, so and in the last unit of the LSTM, we pass it to sigmoid classifier to get the sigmoid classification, like whether it's a mobile tweet or not. Yeah, yeah. From here, Harsh will take on.
Hello. So, hi everyone. We'll be now looking at the second task of this problem, which was entity recognition and sentiment analysis. So, a very concise description of the problem statement would be something like given a set of sentences, find the mobile brand entities present in them and their corresponding sentiments. An important point to note here is that the given set of sentences can be containing variable number of mobile brands, and we need to find each of them and the sentiments corresponding to each of these brands. The existence of a variable number of brands and classification of each of them is something that what makes this task a little complicated compared to the standard tasks of, say, sentiment analysis of whole sentences. So next slide. Yeah. Uh, before going, uh, can you turn next slide? Yeah. So before going through our approach of solving the problem, let's quickly look at the data preparation step, as it was one of the pitching points of our solutions that we proposed. So the data set corresponding to the problem was not provided to us, and we were basically expected to collect the data and their corresponding labels on our own. The data preparation was definitely one of the biggest challenges in this problem statement, as even after trying for a few days, our team couldn't find great data set that were well fit for this task. Obviously, there existed similar data sets like those for aspect-based sentiment analysis, but we still needed some data to fine-tune our proposed model. So next slide. Let us look at the method that we used to create the data set. So after lots of exploration, we decided to use our own innovative ideas to generate data set and their corresponding labels for this task. So what we did is we collected sentences corresponding to each known mobile brands, and these sentences basically ensured that there exists at least one mobile brand in these sentences. After that, we passed these sentences through a sentiment analysis model, and we made an assumption that the sentiment corresponding to the brand is same as the sentiment corresponding to the whole sentence, as each sentence contained only one brand. Next slide. So as you can see in the given image or table, this gave us sentences, each of which had a mobile brand and a label corresponding to them. Finally, what we did is we merged these sentences along with adding some non-mobile related sentences as a noise to those dataset, and that's how we created this dataset, which contained multiple sentences, and each of them had various number of brands and their corresponding labels. So next slide. Yeah, so here are some of the stats for our generated dataset. Next slide. Yeah. So let us look at the proposed architecture for this statement. So in order to perform entity-based sentiment analysis, we used the following architecture. So here, batches of sentences were passed through a pre-trained BERT, which maps each word to a 768-dimensional space. All the known mobile brands were also embedded in the 768-dimensional space using the same pre-trained BERT. For each brand, we calculated the multiplicative attention score A with queries as the brands and keys as the 768-dimensional mapping of the words as shown in the diagram. The blue box shown corresponds to the mapping of words as keys, while the red corresponds to the mapping of mobile brands as queries. Finally, we pass the calculated attention vector A through a fully connected layer, which classifies the sentiment of the brand into one of the four different classes. The four different classes corresponded to the sentiments positive, negative, neutral, or non-existent, in case the brand did not exist in the given sentences. Next slide. So here is just a simple mathematical representation of the multiplicative attention that we used, just for the reference purpose. Next slide. So Janvi will continue from here.
Yeah, am I audible?
I am not able to.
Am I audible? Hello? Yes, you are audible.
Yes.
Yeah. Yeah, so the third part of the task is for all the articles which are identified as mobile tech, our model needs to generate the headline for it. So the strategy we use to achieve this is based on encoder-decoder architecture. Our encoder captures the semantics of the article and pass it to the decoder. Decoder generates the headline from the information passed by the encoder. Next. Yeah. So this slide describes the structure of the encoder. Input to it is an article in any of these three languages or mixed. In the step 1, we generate 768 dimensional embeddings for each word in the article. Those embeddings are passed to LSTM to better capture the semantics. Output from the LSTMs is 256 dimensional vector, which represent the whole article's meaning. Next. Yeah. So for this step 1 in encoder, we use BERT pre-trained model. Here the embeddings that we use is common embedding for English, Hindi and English, that is the multilingual embeddings. Next. The second step is the 768 dimensional encoded words are then passed to the LSTM, which captures the semantic meaning of the article, which could be passed to the decoder. So the next is decoder. Our decoder model is Time is one up. single Please wrap LSTM. up in 30 seconds. And, yes, ma'am, yeah. The encoder passed the 256 dimensional vector to it and it sequentially generates the words of the headlines one by one. So the one challenge here in this task was the input text was Hindi, English, and the to achieve that, we use a common word embeddings in our common embedding for Hindi, English, and English. And for the decoded part, we use only English embeddings. So uh, yes, ma'am. Yeah. Thank you. So now we will begin the Q&A round. Judges, please ask your questions.
Sure, I can go first. So my question was around the data that we are creating, and what I understand is first we are selecting a sentence which has only one brand name, and then we are combining some of these sentences, right? But then that is still not solving multi-brand name presence in a single sentence. So want to know team's thought on this.
Yes, I agree that the sentences that we tried to use contained only single brand, and they did not contain multi-brand because the creating labels for this was difficult. We, generate labels corresponding to sentences that had multi-labels. But for current proposed solution, our sentences has only one brand and a corresponding label to that.
Got it. Okay. Any idea on how you will be able to do it? Because the moment there are multiple brands, the overall problem will become more complex. So can you tell me that one thing that you want to take care of, or one change that you will have to do in your current architecture?
Yes, ma'am. On the fly, what I could think of for now is like merging two sentences uh, together to form just a single sentence, and those two sentences would contain two different brands. So what we did now was merge two sentences as two different sentences to form an article. But what we could instead try was take two sentences and try to merge them to form just a single sentence. These two sentences would contain two different brands, and we would be having labels corresponding to them. So the dataset that would be generated in that way would have a single sentence with multiple brands and their corresponding labels. But we could definitely read more about it and try to get understanding of better approaches that people have used.
Okay, I wish it was that simple, but absolutely. Thank you so much. Jaskaran, over.
Thank you, Rajni. So you called out two brands which are two models which are using for article classification, mobile tech classification. Which one did you actually end up using out of the two, or were you using both of them? That was not called out in the presentation. Connection lost.
Yeah. So there is some connection issues. Hello. Hello. Am I audible?
Yeah.
Yeah, so we use TF-IDF vectorizer because there was a problem like BERT models and the TF-IDF vectorizer were giving the same kind of accuracy. So like because ML models are like more faster as compared to DL models, so we decided to go with the TF-IDF approach with logistic regression.
Okay.
Yeah.
How many features were there in your logistic regression model? Sorry, Pink, I'll just take a minute. How many
Hello.
features were there? Yeah, how many features were there in your model? You're building a logistic regression model. How many features
Yeah.
are fed into that model?
Yeah, there were around 6,300. I mentioned in the slide. I think 6,347 to be exact. I think were the size of the vocab that was there in training the logistic regression.
So, do you think a logistic regression for such a high dimensional data was the right choice?
Uh, I think since logistic regression classifiers like works mostly well with sparse data, like here most of the entries in the vector would be zeros. So I think it would be right, but yeah.
Okay. Go ahead, Prinka.
Um, guys,
Scary.
I could not hear your question, sir. Can you please repeat this?
So I'm saying while you were implementing this, have you guys thought through from a scalability perspective, and do you guys at all think that there's a big gap in your approach from a scalability perspective? Do you acknowledge that, or do you think whatever you guys have done is absolutely scalable?
So definitely, putting deep learning models in the production might have some bottlenecks. But if you look at our architecture, the BERT part is actually same in most of them, and even the LSTM part is same at two of them. So if we had to basically implement a pipeline through them, this computation part, basically the encoder part of time. Only the decoder part is almost different in all the three. But there was a trade-off between accuracy and the complexity of model, and we chose to go with the more accuracy. But definitely we can work upon to improving or increasing the scalability of these.
Okay, thank you.
Yeah, thank you, sir.
I think we're done, Soumya.
So 13 was our last team. We will wrap up here. So thanks to all the judges and participants for your time and cooperation, which eventually led to smooth conduction of this event. So the results will be announced tomorrow at 10 p.m. And if there is any query, you can ask here on the chat box or you can message on WhatsApp.
Sure. Thank you. It was really helpful for us. Quite a knowledgeable connect. Thank you for collaborating with us.
Thank you, sir.
Really happy.
Absolutely. I echo with Jaskaran at this point. Thank you so much, team. There is a lot of work that has gone into from each one of us, given there was actually only 15-20 days to work on the overall end-to-end solution. There were multiple parts to the solution, and we are happy to see that every team has attempted to provide some solution to each of the parts. So completeness was something that was, that we saw across all the teams. And every team has tried to do some innovation or try to build in some approach or solution that is, different from each other. So wonderful to see that. And it was an amazing session. We also learned a lot of things today. So thanks a lot for this.
Thank you.
Thank you, sir.
Thanks, everyone.
Thank you.